So let's see, a lot of times they don't do a great job in explaining this. So, okay, first, how many of you know how to use this already, a scale? Oh, okay. Well, just bear with it, okay? So on this page 2, the back of the front page,
Wait, which one are we looking at, Patrick?
it's called Unit 8, Reading Scales. One of those you picked up the first night. You should have.
This.
Oh, I don't have that one.
Oh, come up, there's some up here. Why don't you come up and get one?
I thought I had one last week.
So can you guys lend one of yours? And make sure you get it back to, last night. Yeah, we don't have an extra one. But
Oh,
she'll-
I have a ruler. How much still have?
no, but you need that. So borrow hers tonight.
Okay.
Make sure you give it back and then, because she can look at Kevin's. Okay, where were we?
Thank you.
Yeah, no worries. Yeah,
We're all just picking up.
I made enough, but you know how this stuff goes.
You have 24 days.
Okay,
Oh, just kidding, I do have it. I'm sorry.
you do have it?
Yes, I do have it. My bad.
Okay, let's go. So page 2, back of our page, above the pictures of the scale, they have a little chart or table. It says scale and smallest tick mark. So all I want you to notice is the word tick, so they call it tick mark. And I could have just said it, but if you see it, it might stick better. So if you look at these scales, and I hope you all have architect versions. There's a regular ruler, 16, it's called 16. So you can use this as an inch ruler if you want. But that's not those aren't the scale, that's not a scale that we would use with blueprints. So you'll see that there's scales listed, the numbers on the end, very end, on both left and right side. So that is, there's usually one's a factor or multiple of the other. So like the 3 is on the right and the 1.5, which is half that scale, is on the left. 3/8 and 3/4 are paired on one. 3/16 and 3/32 are paired. 1.5 and then 1/4 and an 1/8. Those are the combinations. So a lot of your blueprints will be the 1/4 inch scale. So that's probably the one we'll talk about the most, but there's some preliminary stuff I had. Let's see, how's that camera?
The other side.
Okay, every scale designation will have a fraction on one side and a foot 0 inch on the right side. Because that's the way you're going to represent the scale. But it's important to know what that means. And probably be a test question too. So a 1/4 inch on your plan, if you measure a 1/4 inch, that would be equal to a foot on a real house. Yeah. So you can say 1/4 inch scale, but if you really want to talk about it accurately, you need to say 1/4 inch to 1 foot, 0 inches. Okay. Because the whole idea is you're scaling down a real, you can't have a 1 foot equals 1 foot scale, because then you have to have a piece of paper the size of the house, right? That's not going to. So scale everything down. So this is called a scale, and what it does is scales dimensions also. So it's a verb and a noun. And it has all these scales on it. Let's look at the 1/4. One thing that's important to know right off is that the 1/4 and the 1/8 are paired together because one's half of the other's twice the other. So they can use some of the same marks, right? every other mark, as a matter of fact. And you need to know which scale. I mean, you know on the end what scale, but you don't know in the middle, which there's 2 registers. Okay, so each set of numbers is called a register. Yeah, you should remember that. So there's a top register and there's a bottom register. And you have to know which one. In this case, we're looking for a 1/4 inch. Which one fits the 1/4 inch? So this is how you do it. Next to the number is a little set of ticks, hash marks, right? So what they've done is for each scale, they've taken whatever a foot is. In this case, it's a 1/4 inch. They've taken the first 1/4 inch and they divide it into, well, you have to count them because they have different number of them depending on the size. So this is one of the smaller scales. So it has 6, 3, it has 12 divisions in that little, in those little tick marks together. Yeah. Everybody see those that little part where it's, so the first 1/4 or first half or whatever the scale is, inch, will always be those tick marks divided up. And they get as many as they can fit in there so you can read it. They, you can just barely read this 1/4 inch. You get to the 1/8 and they don't even try because it would be too small. You couldn't actually print it on the plastic. So, but as it gets bigger, like if you look at the 1 inch right across from the 1/4 inch below, they take a whole inch because it's an inch scale and they divide that. So they have many, actually more divisions. And they can actually number some of the divisions. They have 0, 3, 6, 9. So you can even get to that point and then go to the numbers after that. So everything's designed to help you read as quickly and simply as possible. But when you look at those ticks back on the 1/4, you notice that they're on the top of the scale, like the 0 line runs off the top of the scale. That means that it's the top register all the way across. So you're going from, no, I'm wrong.
The 8 is the top one.
Yeah, you're right. So I'm wrong. So how are we going to figure that out? So they're all on the top. So what you have to, okay, here's the way I said it wrong. I was wrong. When you want to know which register goes to the scale, in this case, we're going to look at the 1/4 inch one first. Look at the one where 1, this is marked 1, but if there was a 1, sometimes they don't mark them. They'll do a 0, a 2, a 4, and they won't mark the 2, the 1 and the 3 and the 5 because it takes too much room and it clouds it. So a lot of times for space sake, they'll skip. But look at, even though it skips it, you can see where the 1 would be between the 0 and the 2. And see what that 1 is. It should be a 1/4 inch because the scale is 1/4 1 foot. So if it's 1 foot, then it will be a 1/4 inch long. And as carpenters, not as beginning carpenters or non-carpenters, but as carpenters, you should know visually the difference between a 1/4 and 1/8 of an inch. I mean, 1/4 is twice as big, and you shouldn't confuse them. So you look at that and you go, oh yeah, that 0 to 2 is, there's 2 quarters in there, the 1/4 and the 2nd 1/4. So it's the bottom register goes to 1/4 inch. Yeah. So that is the only way you can tell. Actually, there may be scales where we do it differently, but I don't know. Do all of you have that? All the scales go to the top. I mean, all the tick marks are coming off the top. Okay. So if you were doing something with the 1/8 inch scale, it happens to be on the left side. And so you go to the right. Oh, that's the other way you can figure it out. Is on the 1/4 inch scale, you're going to start with 0 and go up. So you start with the scale that has a 0 and goes up, not with the one that starts with 92 or 93. That wouldn't make any sense. It's been a while since I've done this, so I'm remembering as I go. So if you look at the 1/8, it's the same thing. It goes from 0, and they don't do anything before 4. They don't mark 1, 2, 3, 4 in there. They don't mark 1 because it coincides with 46, and that would be too confusing, So when it's confusing, they just don't number it. They'll number it every 4th one, and you just have to figure that out. Okay. Now, there's a way we're going to read these on plans. That's what we're headed for. So I've read a lot of explanations, and I don't particularly like the one in the book. Let me see if that page is to scale. Probably not. So,
Oh,
oh, okay. So let's take the education plan. That's this one here. And put that on the desk where you can see it. Instead of dealing with things that are photocopied and not scale anymore, let's just go to something that's photocopied to scale. And let's go to the floor plan, which is A5. With A5, you know, you can pull it back or not. This is a lot of what you start measuring into it, just stick your plan, floor plan. So let me know when you've all got your plan.
don't worry.
Turn to A5. Zach?
Yeah,
So, you know how to use a scale, architect scale?
Yeah.
Okay. And Ariane, do you? And Jose, have you guys used them before?
Yeah, I've used it before.
Okay. Tyler, how about you?
yeah.
You have, okay. So we're gonna take the house prints, which is something you got in your computer somewhere. It was actually the first set of prints I sent you. And we're going to go to A5 on that set. It might not help you out because it's on the screen and it won't be to scale.
They're gonna be holding their scales up to the computer screen.
Yeah, and it won't be the same.
You caught me, Lewis.
Yeah, so I'll figure out something for you guys in a second. So what scales are 99% of all floor plans?
1/4.
Quarter inch, okay. So go to your quarter inch scale. Some of you have colors on your thing, and usually the blue or the red is between the quarter inch and the other one, so you can go get to it quickly.
Green.
I forget what color.
Green.
Green?
Green.
Yeah. Okay. Green's new. They used to all be red or blue. You what, Eric, what, do you have color, any color on your?
No.
No, okay. Well, the numbers are colored. What numbers are red? What scale?
Quarter inch and
Oh,
1
yeah,
inch.
okay. So they just made all the numbers red for quarter inch, because that's the most used scale. Yeah, if you became an architect or you worked in a construction office on prints, you would probably end up getting the scale that was easiest for you to use, the one that you could use fastest. And that's probably a personal thing for everybody, you know. So we got the quarter inch. So this is how I do it, okay? Oh, on this plan, the A5, right? Everybody got that? On the upper right-hand side, there's that walk-in closet from that master bedroom, upper right. And that bottom wall, it's got a window in it, and right, it's the wall that faces the bottom of the page. Yeah. So we're gonna measure that. We're gonna use that one as our test. So what you do is it's very rarely that any dimension is gonna come out even, like 20 feet even or 10 feet even. That's not gonna mostly be the case. So what you have to do is figure out where it lies between 6 and 7 feet, between 7 and 8 feet. So then when you measure 6'5". So the way you find that out is you're going to start on the right-hand side for the scales that start on the right-hand side. So quarter inch starts on the right-hand side. So you're going to start with that. So you're going to take that 0 at the beginning of the tick marks, and you're going to put that 0 on the right-hand side of that wall, the right-hand corner, the outside corner. And then you're gonna look down to where it butts the wall adjacent to it. And it's gonna be 10 foot something, right?
Yeah.
You see that? And you go down and find 11. So it's not at 11, right? It's between 10 and 11, yes?
Yeah.
So that's the first thing you establish. So it's gonna be 10 foot something, right?
Mhm.
So now you take your 10-foot mark and you slide that right to that place where it intersects that other wall. The 10-foot mark. That means the tick marks are still going to be on the right,
And it shows you on the right.
but it shows you on the right which of those tick marks is at the edge, is the length of that wall.
That's so
And these are hard to read, granted, quarter inch, they're pretty minute. But it looks like, well, it's over halfway, we got 6 inches. And each one of those marks is an inch, so it should be 7, 8, between 8 and 9, I'd say. 10 foot 8. Everybody else see that?
10 foot 8, yeah.
Yeah, okay. So I think that's the best way to do it. You start with a 0, find out where how many feet it's gonna be. So it'll be a little bit more than, you're gonna see the last foot you passed, which was 10 in this case, you didn't get to 11. So then you start with a 10 on that side, and then you look at the right side, you get how many little inches, 10 foot what, 10 foot 8. So that's how this is designed, and it's pretty cool the way they do it, it's pretty ingenious, actually. A lot of people say, well, why is it so confusing? Well, for one thing, you gotta get all this information. They consider all these scales probably will be used. And most of them will, in plans I've seen. So you gotta have all those scales, and they're fitting them together, which saves room. Otherwise, you have to have 2 of these. So you got double scales, they use each other's notches. And then they put tick marks on for at the beginning of each scale. And you just gotta figure out which way you're going. That's to get your orientation. But that's all it is, actually. So let's do another one, okay? Let's take the bearing wall, not too far from that. It's a wall going left to right across the thing. It's this 2x6 bearing wall. It's between the closet and the bedroom. See that one? Let's measure that. So we'll put the 0 on the right side. And we'll see where it. Don't go to the end of the closet, but go to that. Is that a wall? Yeah, go to that wall. You know what I'm saying? Or just past the closet. Go past the closet wall. We don't care. Well, what do you think? No, let's go to the closet wall. Because that's a dimension you'll need to frame anyway.
Like 15.
So 0, and then, no, just to the. Yeah, don't go to the wall all the way to the left. See the closet wall that's coming down part way, where the number 8 is. Yeah, just go to the inside of that wall. We're going inside wall and inside wall.
Which bedroom?
Bedroom.
The upper one,
Bearing wall,
it's between that master bedroom and the,
In the master bathroom?
no, below it, the bedroom 2. Where it says
2x6 bearing wall.
Yes, and we're going inside of the closet. So put your 0 on the right side, because that's where the quarter inch scale. And then see how many feet short of that closet wall. I get 10. Does everybody get that?
10 exactly.
You get exact?
No, maybe a hair heavy.
I got 10
Okay.
too.
Okay, so we know it's at least 10.
10 foot 2.
10 foot
So
2.
then put the 10 against that little closet partition there and read the other way. And that'll tell you how many tick marks and how many inches over 10. So I get 2, at least 2, right? 10, 2? It's probably between 10, 2 and 10, 3. Now, it's nice for architects to mark it because you could read that 10 foot 2 instead of 10 foot 3 or 10 foot 3 instead of 10 foot 2. But so here's the thing. Let's add up now we can. Yeah, we can. Let's add up well, that's something we have to do too. Fraction math. Let's see how the closet, the bifolds are the center of the bifolds are given 2'9¼ then 4'11.5" between them, and then another 2'9". Add all those up, and then we'll subtract the thickness of the wall and see if we get 10'2" out of it.
Can you say that one more time?
Yeah. That closet that we just measured,
Mm-hmm.
if you go down a little bit outside the bifold doors there, you see three numbers, 2'9¼
Yeah. Four.
Yeah, add those three, 2'9¼ 4'11.5".
10'6", minus 3.5.
So are we gonna call that, we're gonna call that 3.5? Let's do that. Because if you're building it, that's undoubtedly what it's gonna be. So this is where scratch paper would be good, because I don't want you writing on the plans. Remember I told you to bring some paper. So you could write on your handouts, because those are yours. So what'd you say? I'm sorry, 10'6", was that total?
10'6" minus 3.5.
Yeah.
10'2".
So we're just checking it against what the architect has. So he has 10'6" to the outside of that wall, subtract 3.5 inches, and we get 2.5, 10'2.5". That's what we said there. And that's what we said, it was between 10'2" and 10'3". So, but it's better to check this, because like I said, that's really hard to read, you know, those little ticks, especially if you're old. But you know it's a 3.5-inch wall, and you know it's and the architect has said it. So I would go with that rather than actual reading it. That's interesting. Now, sometimes the architect will draw 3.5, 2x4 wall, 4 inches. That used to be a convention, and not worry about that half. This one, they're exactly 3.5. They look more like the 3.5. So maybe they're going back to that, or I don't know. But then they used to do 6 for the 2x6 and 4 for the, because it's a pain in the ass to draw, you know, 3.5 when you're drawing this. Much easier to draw 4, right?
Mhm.
But these are, let's see, I think these are pretty close. Let's see the, yeah, the 5.5 is a little bit less than 6. All right. So let's go to, in that same set of plans. So we're not gonna look at, details per se tonight, because that's another lesson that I wanted to get one to measure, but this one doesn't have anything to scale. Because it's an educational plan, remember? Scale, none. They should have another word besides none. It has a scale. Scale not specified, what they should do. NS.
Here, the column on the. These are different L3X equals 1.
Yeah, where's that? What page?
That is S1.
Oh, God knows where that is.
S1.
Toward the back. Okay, good. Oh, the cabinets? Yeah, okay. So S1, it's down toward the end. Everybody got that? Turn to S1. So we're gonna look at the cabinet elevations, which are not in every set of plans. This one has them. So we're gonna look at them. And what's the scale of those cabinets? And Ben can't answer that. Yeah, see with the bottom 3, it's the 1 foot. So that's a different scale. So let's, unfortunately, it's also on the right. I was trying to get a left. I'll find a left one. So let's measure. Oh yeah, let's measure the width of the refrigerator. I just remodeled my kitchen. The width of the refrigerator is extremely important. You can get really messed up if you don't take it into consideration. Okay, so this one looks like what?
3, maybe 3.5.
Yeah, usually they make them 3 even. They try to make that standard. So, but yeah, so you know, you got a 0, then the 14's for the other scale opposite, so you skip it. It would be 1 for our scale, but it's not marked. And then 2 is not, it is marked. And 3 isn't, but it's where the 13 is. So yeah, you all see that there'll sometimes be an alien number in the place where you want it. You just have to ignore it. Because it's not going to be 13 feet wide, you know that one. Yeah, so that's one of the difficult things is how they've had to piggyback the scales to make room for everything. The quarter-inch seems to be easier to do that with, but let's see if we can find a, you know what I need is a 3/4, 1, 1.5, 1/8. Anybody?
This other plan is two.
Yeah, why don't you look on those other plans like shower?
First page has 1/8.
1/8? 1/8, oh, your site plan, yeah. Okay, so that's a good segue to talking about site plan. So the other set of plans you have that says AABC on the upper right-hand corner. That's our illustrious drafting team here. Who is related to LC? That's why he uses the name. Everybody goes, who's that? You don't know?
Say that again, sorry.
LC? That wasn't his full name, obviously. Sid means what? Something. In Spanish, CID, what does that mean? Does that have a meaning?
CID? No, sir.
Does the word CID have any kind of meaning? Sometimes names have meanings, right?
Right, but
I think El Cid was an appellate, was what they called it, so it means something like brave one, foolish one, or something. He had a much longer Spanish name. El Cid was what we call
So
him.
he was a Castilian knight.
Yes. Yeah. He was a knight who switched sides. He fought on several sides. Sometimes he fought on the Muslim side, sometimes on the Christian side.
Del Cid was a place in Spain, Vivar del Cid, Spain. So Del Cid is from
Right.
Cid.
Right. Right. So he said he was related to this guy. I asked him, because you don't hear that name a lot, right? Is LC the common Spanish name?
never, I just heard it like he said in literature. but-
Yeah, in literature, right. So I asked Armando and he said, yeah, he was related. But, you know, we all say that about famous people. But he could be. Anyway, that's what AADC stands for. So the site plan is either 1/8 of an inch to a foot, like this one, or since it's a civil plan, often done by a surveyor and an engineer, they'll use an engineering scale. And they're about split. I wish they'd all go with 1/8 of an inch because that's the kind of rules we have. That's why I have an engineering scale, because sometimes site plans have that. And if you were doing this in an office where you were doing takeoffs and stuff, you'd have to have an inch scale handy also. I brought that up in a meeting the other day. Nobody thought that was significant.
It's like having the engine.
Yeah, like they can't translate it, like the site plan, remember the distances were 37.7 feet, you know? So there is no way you can measure that without translating it. So that just adds more work. And a lot of people that read plans aren't really smart enough to do that unless they were taught at some point. It's not obvious. If you take our math class, you'll learn to do that first. Right. Or if you have a construction calculator, you can put in the decimal and bling and they're slightly different, but inches and feet. So that works too. Okay, but you know how many crazy traditions there are in the world, right? That need to be thrown out. Vast number. Okay, so 1/8 of an inch is where on the scale?
Opposite from the quarter.
Yeah, next to the quarter, part of it, integrated into the quarter. So, let's count the ticks. So there's a middle one, so that's 6 inches, that's half a foot. And 3 others, right? So they would be 2 inches apiece. Yeah, so see, they vary, and what is a good thing to do is if you're going to a scale that's different than a 1/4 inch, which you'll be using most of the time, kind of look at the ticks and figure out what those are and write them down on the scale if you use it or on where you're working. So you know what each of those means. Because you might just assume they're always one, but they're not. Okay, so I was looking at this outside wall and let's see how much it is. I don't know if it's on the scale. What do you think?
The front wall.
Yeah, that big dark one. So I don't know. Yeah, it's like close to 6 inches, right?
Okay.
So we should take a distance, all right? But we can't go to a floor plan for the distance because that will go back to 1/4. So, okay, so there's that upper left-hand corner, there's a setback of 10 feet. Let's see if that's right. We'll test Armando and see if he drew these right. Oh my goodness. Upper left of the lot, not the page. There's it says 10.0 below shed relocated. So measure that and see if it's actually 10. We're gonna confirm his measurements. So this one, you'd start with a 0, like we did on the other side, and then you'd see where that setback line is, and it happens to be, well, it's not a really precisely drawn plan, it's a little fuzzy, but it's at 10. More or less at 10.
It's not that.
So you don't need to use a tick, it's a whole 10. So that dimension will be a whole number because setbacks are a whole number, it's in the 6 or 8 or 10 or something. But usually in a house, architects don't. No, they're not worried about that. There's a movement, advanced framing that's trying to save wood. We haven't talked about that yet. Maybe in another class.
Building agreement.
Yeah, building agreement did. So one of their suggestions is that architects do things on modules, like have a 20-foot front and have, 4-foot thing even. 20 foot, so you can get, like, if you're putting sheathing on, if you put it on vertically, you can get 5 pieces across, like that, so you don't waste any. But it's really hard because, you have a wall, you have walls that join, right? So even if they have to make sure that the wall that joins isn't itself 20 feet and then adding on the 3.5 of the wall that's joining, then it throws that entirely off. So the architect has to be really on his toes and know which way the walls are going to split. And that's something builders hardly know, they don't show it on a plan. They just show the walls join. They don't show the actual, which one's long and which one's short. They're just both hollow, right? Like go to A5, the one we were just at, the floor plan, not other plan. Does this have page numbers? Yeah. That'd be sure.
6 to 12.
Huh? 6 of 12?
It says about a five
Yeah,
page
I guess
number
you-
of the
Is that accurate?
6 to 12,
Does this start with 1 of 12? Okay, thanks.
Starts
Yeah.
with 1.
Yeah. It didn't start with 1. Thank you, that's the way to do it. So if I say page number, like page 6, it means 6 of 12. So that's the way to do it, okay. So see, well, these walls are shaded, but see, on the very top, where we were looking where that master bath is, very top of the page to the right. See where the master bath wall hits the outside wall? There's no lines there, you can't tell. That one almost surely would be short because they butt an outside wall, but if we found an interior one, like in that bedroom 2, where we just were where the closet is, you can't tell which is long where that number 4 doorway is. Usually they would make that long wall go long, but you know, there could be reasons why they don't. So, but what I'm trying to say is they don't show it. On none of the corners do they show a line that tells you which wall is running long. Everybody see what I'm driving at?
What do you mean by driving?
Okay, so look at the upper right of the whole building, the master bath, upper right corner. Outside corner, 2 walls are meeting there, right? There's no line in there which tells you which wall goes past the other one.
Okay.
One's got to be long, right? One butts into the other.
One goes to the outside and one butts.
Yeah, so they never show that anywhere. You look anywhere in the house, and they never show that inside line. It's just, they don't do that. And they wouldn't know, like a builder will take this, and a builder has to take this. The guy who's gonna build it, whether it's the crew leader or supervisor, superintendent or whatever, and he will probably mark those, right? When you get plans, are they marked?
I know I would decide which ones run longest by which wall I'm gonna stand first,
Yeah,
because then that way I don't have to slide the other one behind it
right.
and it's right in place.
Especially on a second story where there's no room, there's a drop off. You don't want to be lifting walls out over the blue. So you want to have the long walls in first and then the in ones just stand up and go in. So you're not, I mean, it's the same thing you said,
Yeah.
except it's even more important on the
Yeah.
height.
Even on the first floor, yeah. the less-
So carpenters and advanced carpenters, which would be the people that were calling the shots, you know, the crew leaders or the superintendents, would go that. I mean, there's other things also. There's other expediencies that might alter that, but basic things like that, architects don't know that kind of stuff. So that's why they don't do it. And there might be all kinds of reasons why it could shift not doing it that way. There might be some kind of reason why they did that, but so when one of the units in this class now later on is constructing from plans. So that's one of the first things you'd have to know how to do, in order to build a wall, you have to know the length of it and where it's going to go. So you have to decide which one of these is long and which is short everywhere. So that's the kind of thing we'll be doing when we get to that unit. You know, because builders just don't take these and automatically erect things. They have to interpret all kinds of stuff. And it's not on the plan, and only someone with experience can point it out. So we'll do that later on.
But it's definitely that you go with the walls all around the building and then you just move it to the interior.
Yeah, of
right?
course, there's some obvious things. Yeah, you do the outside. Yeah. But there's little exigencies. I'll try to, I mean, I know there are because I've built for 50 years, so, but I'll try to come up with some where you might have to go against some of those general principles. But that's partly, you know, the architect draws these plans and then the builder has to make them buildable. So there's a lot of work in that. You know, that's why they give you the plans. The boss will give you the plans, say study these for a week because they're going to be at that job and you got to know what you're going to do. So you go home at night drawing all these lines. Yeah. Okay. So any questions about so far? We're not done with the scale yet, but any questions so far? Yeah.
Can you explain the 1/8 a little bit more?
Yes,
1/8.
absolutely. So we got to go back to the other plan, right?
Yeah.
Yeah.
I just didn't understand how you got that sense.
This, even though I'm such a great teacher, I've explained it really well, but this is a hard thing for people to grasp. I mean, sometimes we grasp it the first class and then you forget over time. So I'm willing to take all the time in the world because it's fundamental. You can't go forward. Okay, so we got our scale and we got the 1/8 inch, right? And it's going to start at the left. Yes, is that right?
Hold on.
You guys at home, you can't see the plans, but does anything I'm saying make sense or?
Yeah.
Yeah, it's all making sense. I'm following along with my scale.
Okay, okay.
Yeah.
good.
Are you
Thank
holding
you.
it up to the screen? No.
Yeah, I told you, this thing here comes with this thing here, this book here comes with the same thickness pouch that has plans in it. But they've all been photocopied, so none of them are to scale, you know, the scales on them. You put your ruler on it, and it's like And then plus they're old Midwest designs, they're still out of it. So I said, you can charge me $120 for something I can't use half of to begin with? I don't think so. So that's why you get this crappy handout, because my photocopying skills are not so good. Okay, so Matthias,
Mhm.
where should we go?
Can you show me that 10-foot thing? again?
Oh, yeah, okay.
I just don't
So,
understand that.
so
Like,
you gotta find out what we're talking about. So upper left of the building.
Oh, upper left.
So the upper left corner of the house,
Mhm.
the black dark line, you're there. And then just another half an inch diagonally to the left of that is the 10-foot zero. You see that?
I
It's
see,
written 10-foot zero.
I don't see 10-foot zero. Maybe I'm on the wrong one.
Oh,
Oh, my finger is covering it.
okay, okay. Okay, so you got that right. So we're gonna measure between those slashes.
Mhm.
And what you do is you put, like, we don't know, well, this is 10 foot even. So say we're not measuring something that's unmarked because we want to know what it is. Say we want to verify that that was drawn right.
Uh-huh.
That makes sense. So, but we're going to go about it the same way. We're going to take the scale and we're going to put it on 0 on the left slash, because we always start with a 0, right?
Mhm.
And then we're going to look to the right and see what numbers under the right slash, less than the right slash, but it turns out 10's right on the right slash.
Yeah, I see like a 20.
Oh, yeah. Okay, got you. Got you. So you see like 40, 42, and then,
No, yeah, 27.
uh-oh,
27.
wait, what scale you got?
The 1A.
Oh, what is it? 27?
This is.
Awesome.
We're just reviewing the 1A.
So the,
Are we measuring the 10?
Yeah.
so the 0 goes to the left side.
Page 85.
There.
We just came back to the 1A.
Yeah, we're using the other plan just to show the 8, because the 8 starts on the left. To get you used to both ways.
Oh, it's that.
They had a decent detail
Okay, thank you
page.
so
That was
much.
half inch, 3/4. Yeah, they don't. I don't think he does either. We'll look at his. So, did you get that?
Yeah,
Okay, great.
thank you.
So it turns out but it's hard to read because the last number is 8. And then 42 is where the 9 should be. And then it's the next one, which then would be 10.
I got really confused. I thought we were measuring down here and then up here and up.
Okay. Just so you got it. So let's look and see if there's another scale besides 8
There's a 3/16.
3/16?
Yeah,
Where's that?
that's 3 on.
What kind of scale is that?
And 332s.
3? Oh, not on the
On the SIDS plan,
school plan,
not the school plan.
not the school. Oh, the foundation plan, S3.
Yeah.
Thank you. That's great. That's good. You know why he did 3/16? Take a guess.
There's a lot to tell you.
This is a preliminary set of plans. He's not getting paid for these until he gets the job. They may look at these and say, we decided not to do it. All that work would be for free. So you do a minimal set. So you're proud of everything. You don't want to waste blueprint paper. So you never in a regular set see a roofing plan and foundation plan on the same page. But on these, they scramble them all together and then they have the client look at one and the client says, yeah, that looks good. We'll take the job. Then he'll do a real set. You look at these details and they're boilerplate. You know what boilerplate means? It's just a template you can get out of the book. Because he hasn't got the job yet. So the plan has to have those. So he just has this general set. They're so general, they don't mean anything. Then when he gets the job and he does a real set of plans, then he'll find out what details need to be in a detail, and then he'll draw it for real. So this set of plans is not good for details, but I didn't get into that. Actually, one of the things I added for is a roof plan, which we'll look at later. So really, you don't always see roof plans because usually roofs are pretty simple. This is a remodel, and they've added rooms that makes the roof all screwed up. So they had to kind of do some fancy stuff for it. So he needed a plan. So and we'll look at that later. It's really interesting. So anyway, 3/16, so let's find out where that is. 3/32 and 3/16 are on the same.
We're on that, yeah, that one.
It's across from the.
Oh, which is that?
Yeah, oh, I'm sorry, S3 on that AADC.
Oh, it's on this one.
Yeah. So let's confirm. Let's confirm a couple of dimensions. Yeah, so this is AADC, right? That's the set, you know what set that is?
Yeah.
Okay, and then it's S3 toward the back? Okay, no, I thought you didn't know where it was.
No, we're right here with you.
Okay, good. So, let's do let's verify a couple of dimensions so you get used to using it, and then we'll find a place he did dimension, and we'll all measure until we come out with the same thing. So on the front, let's do that 15.8 at the bottom left front. It's the width of that. Well, this is interesting because it's it's a foundation plan, but it's the inside of that foundation. We don't care. Just where those two slash marks are, around 15.8. So 3/16 is on the right. Yeah, so it's like a 1/4 inch. So we'll put the 0 on that right slash mark. And then we'll go to the left and see the nearest full number before the left slash mark. And that would be, oh my God. These are nasty ones to read.
The lines are just so thick, it takes
Yeah.
up like.
Yeah, no, I hate the scale. So it's the bottom one because it's ascending going left. So I can see 14, 15. I'd say it's 15, just under 16, so 15 something. Everybody agree with that? But so then slide it over so the 15 is right on that left slash. And then go back and see what the ticks say on the right. So it'll be 15. I don't know,
I got 15 and 9.
9, I'd say, yeah. They're pretty small. So this is a good lesson, not to think that that's exactly right, because it's too hard to read, and you don't know that the architect took the time to draw it right either. So if you can, this word is verifying this, but if you can find other things that will add up, do that. If you can find other ways to measure that or find it on the plan to confirm what you measure, that's always best. Because if you're an inch off, someone may have a tissy fit, so. They have it depends. If you're doing a building for a rich client in Montecito, a lot of times they get involved in the building. I don't know if you know this, and they see things that aren't really relevant to them, but they think it's got to be perfect. They're perfectionists. It's probably how they got their millions. And so if something's a half an inch off, they'll go nuts. They'll say, hey, look, we didn't spend $10,000 to set plans to have you guys build it a half an inch off.
Come on, guys.
Yeah, so you get all kinds of clients. These clients couldn't care less if it's a half an inch off. In fact, they didn't care less. They didn't even take the job. That's why we have the preliminary set. And I went by the house and I went, it doesn't look like that. And I talked to Mike, yeah, they didn't take it. Oh. But yeah, so it's always good to, cross check if you can, otherwise the more expensive home, the more finely detailed they are because there's more potential litigation possibilities. And so the plan is a legal document. So both sides have to be able to win an argument over how they interpret the plan. So if you were the builder and they said, this is off, you'd say, here, come here. See this ruler? What do you think? And it would be so close to that line that you could probably, a judge would probably say, no, it's too close, you don't have a case. I would guess, who knows? But the plans are legal documents, so you have to really be careful. And if something doesn't work or you have to change it, you have to go to the architect because then he'll change it he'll document the change and then nobody will argue about it. And then he'll have to tell the clients too. He'll say, oh, look at, the contractor says this is too close to tree roots, can we cut it back 6 inches, you know, so, sure. Or no, pull out the tree, you know, we want it right there. But that's part of the process too, is adapting to all the things that might happen. Okay, so did everybody get that 15.8 okay? So go back, put the 0 on the left side. And it's between the 48 and the 46 on that other scale, so that was no, what am I saying? Do I have the right scale? No, I have the wrong scale. Exactly half of it, okay. So it's just under 16, so it's gonna be 15 something. And we'll put the 15 on the left slash, and it's not marked 15, it's between the 14 and 16. And then we'll go back and look at the right and see how many over 15 it is, and then, you know, it looks like that third long mark, which would be 9 inches. Oh, 8 inches. Oh, okay, so let me see it. Yeah, actually, it looks more like 9 to me. Isn't that what you thought too? Yeah, but it says 8, huh?
It's like you measured to the inside of the line.
So where that's given on the plan, we're just doing this as an exercise in class. But where that's given on the plan, you can go with that 15.8 because that's legally what it is. So if your scale reads different, say, you know. Now, if it was drawn bad, but you're gonna go by this, you gotta make sure everything else adds up and makes sense with that, because they may have drawn that one wrong and these right, and they don't fit in the real world, so. That happens too. Okay, so we good, and you know, tomorrow, we'll revisit this to make sure everybody gets this, you know, we'll go over and over, because it's not that straightforward. Okay,
So your best bet when in doubt, just go by the number that is.
yeah, the numbers are there, so you can always go by those, but you know, they leave a lot of critical numbers. They're not builders, and sometimes they don't realize something's really important and they won't mark. And it should say on the plan, I don't know, I haven't read this on the plan, but I bet it says it. Especially an expensive house that has a big stack of specifications. It will say all dimensions are final, and if, you know, if the builder goes by those, it's not responsible. So that,
Usually on renovations, they give you very few numbers.
yeah,
Because they're, you know,
yeah, because that's true too.
They're designing them when it still looks like
Yes.
this. And
That's a great point. Renovations, they can't even measure because you can't get inside walls. They could have all kinds of brick on them and stone, and so the architects are doing their best guess too. So they would never hold you. If it was too radically different and it made a window really awkwardly close, you'd go back to the architect and say, well, you know, this is what it's gonna look like. Is that what are you okay with that? He'll say, oh, no, let's move it. So, you know, where you have to use your judgment as a builder. If something is not right, even though it says it, double check it. Because you won't be blamed, but you may have to tear it down and build it over again, and you don't want to do that either. That's a morale loser, even if you don't lose money.
Yeah.
You know,
time is money, so.
you're so geared to that.
Keep
and
the
to have to-
questions to a minimum.
Plus you do, but you do hard work, you know. What if it's finished work and you spend hours doing this really beautiful fireplace mantle, and all of a sudden they say, oh, no, you know, we decided we wanted an inch less on each side. You know? So, okay, let's see what's left on this handout. And you can read the handout too and go over it to reinforce it. They have some stuff on engineering scale if you're interested in that. You don't have a engineering scale, but the engineering scale, go to page 3 at the bottom. I marked it 3 at the bottom on this handout. It shows at the top right, it shows how engineering scales are, how they occur on a scale. So 1 inch equals 20. So if it has a 20, so this has a 20 here, this register. So that's 1 inch equals 20 feet. Right?
That's for engineers.
Engineering, yeah. So they don't do it fraction equals a foot. They do it Yeah, and so 1 inch could equal 20, 10, 30. You know, whatever. But that's how that reads.
It's the same principle, but the scales are just for larger.
Well, yeah, and they don't, and you know how on a architect's, everything's equal to one, some fractions equal to 1 foot, but here you've got 1 inch equals 20 feet. So it's, yeah.
But once
It's
again,
a little
it's the same principle.
Yeah,
as far
yeah,
as the-
yeah, it's a scale proportion. Okay, so, yeah, if you're interested in art, engineer scale for whatever reason, there's a little bit of stuff on it here. See what else they have. So look at on page 5 on this handout. The top drawing of a scale is 1.5 inches. Okay, now look at how many ticks are in that one. That's one you're bigger. The 3 inch, which is bigger. But there's enough room there because you're a whole 1.5 inches across, right? So that's plenty of room to mark. So they even mark a 0, 3, 6, 9. But look at, and others have marked that too smaller scales, but look at what's in between them. Actually 0, 1, 2. So actually they've got the feet marked, but that's not where it stops. There's still one smaller, which would be 6 inches. And then there's a little tiny tick before that, which is 3 inches. So all those are, every line on there is 3 inches apart. Yeah. Everybody see that? If it goes from 0 to 0, 3, 6, 9.
Yeah.
Yeah. So if you go back from 0 to 3, go to there's a long mark for the 1 and the 2 inch. So go to the 1 inch. And so there's still a mark. So that would be the 6 inch, halfway between 1 and 0. And then there's still a little mark. So that would be 3 inches. So each of the lines on here is 3 inches. And the bottom picture is also interesting because if you don't have a scale with you, possibly get to a job site and your kid borrowed it for homework and you don't have it the next day. You can use like Eric was telling me, you can use a tape measure because it's divided into 1/4 inches, among other things. And so you can just consider that. So it works really good for 1/4 inch scale, but you have to count up everything. It's not. So each 1/4 inch mark on your tape is a foot in the real world. So you could take your tape measure onto your plan and count the number of quarters and fractions of quarters. If it was, 3/4 and then another half of a quarter, it'd be 3'6", right? So, and you can do with the other scales, you can do with every scale, but it's a real pain, like 3/16 would be a real pain in the ass. Because, it's not marked that way. It's marked for 1/4 and 1/8. 1/8 you could do easily, 1/4, half, 1.5 would be hard. But it's a good thing to know because you do misplace scale. Oh, and the next page, 6. Remember I told you that normal doors and windows are a dimension to their center line from the end of a wall or the inside of a wall or wherever you're measuring from to the center line. The top one's a brick wall or masonry, and that's different because where that masonry ends is a pretty good number, but where a window ends and begins is not so defined. So they just said, heck with it. So they go to the center. And it's really great for the builder too, because the architect or the client can't argue with it. You've gone to the center and then you split your window in half. What else can you do? So you're safe there. Okay, now the fun part we have is we're gonna measure some lines in a minute. But on page 7, there's a little thing called adding and subtracting dimensions, the right-hand column. So one thing you gotta do, because you're measuring with feet and inches and fractions of inches, is you've got to be able to add and subtract all those. So some of you know how to do this cold already, I'm assuming, but some of you may not remember, or may never done this. So it's like, remember when when you're adding, you add in columns, right? When you're in elementary school. You have 43 and 36, you add the 2 columns, right? You carry, if it goes over 10, you carry 1 over. But these aren't divided in tenths. They're divided in feet and inches. So 12 is more like a base 12 in a way. So say you're adding, the first example is add 3 foot 4 1/4 inches to 7 foot 9 1/2. Everybody see that? It's on page 7 of your handout. On the right upper side. Page 7. I told him I had a class on Monday and Tuesday. Guess he didn't take it. So you'd start just like you do in arithmetic with base 10. You start on the right, fractions or if there's no fractions with the number to the right. So you add the fractions. So 1/2 and 1/4, that's 3/4. Now, does everybody see that 1/2 and 1/4 is 3/4? I mean, some people have forgotten that or don't remember it. Because I teach this in the math and I'm always surprised what people forgot.
There's 2 sevens.
So did I hear a yes for everybody?
Yes.
1/4 and 1/2. Y'all remember that? Or 1/4 and yeah. So they actually broke it down here for you. Instead of 1/4 and 1/2, they changed the 1/2 to 2/4. So then it was a matter of just adding the numerators. But so that you got to know how to do. If you kind of vaguely know, which is not unusual because most of us had horrible math experiences. And you're in the program, you're going for the certificate. This next summer too, this is an unashamed plug for the class, is deals with a lot of this stuff. The whole first part is about fractions because it's so, not only just adding fractions, but you have to change from decimals to whole fractions to Carpenter's fractions. If you have 1/5, you can't measure that. You got to change 1/5 to something around 1/16 or 1/8 or 1/4. So there's a method for that. So we spend time on fractions, translating them back and forth, adding, subtracting, multiplying, because all that's stuff you'll need in construction. Well, anyway, so on here you add those. You've got the 3/4 for the fraction. Okay, so 3/4 of an inch. Then you're going to add the inches. You got 9 and 4 is 13. Whoops. Just like if something's over 10 and you have to carry the 1. If something's over 12, because there's 12 inches in a foot, you got to put down an inch and carry that 12 inches or 1 foot to the next side.
But they haven't done it.
Well, they haven't done it yet. They do it as a second step. I was looking for it. So then you do the feet. 3 and 7 is 10, and then you have to add that 1. Don't forget it. So I'm not going to go into it here, but there's really great ways you can mark if you do it, with arrows and whatever, that'll really keep you oriented so you don't get confused. And, just like they say, when you carry something to mark, the extra 1 up above it. So we'll go into those in that class too. So then you got 11 feet 1 3/4. So here's one here too. This is a great example. It's one underneath. On us, it shows a dimension on a plan, and they give you the outside dimension, and they don't give you the center one. And it may be because by the time you get done building or laying out the other 2, you don't need to do that other one because it's what's left automatically in the building process. But sometimes it's not, and sometimes you need to know that one by itself. So then you have to interpolate, you have to take what you have. So this might be abstract for some of you, let me know. You've got the total measurement there, the 24 3-inch. And then you've got two of the included measurements, 5'6" and 3'1". And if you want to find the center one, does everybody know that you would add the other two and subtract from the 24? Is that obvious to everyone?
For the 24.
Yeah.
I got that.
So they do that below. They add the 2, you get 8, 7, and they subtract that. And here, because the inch on the bottom,
Is greater.
yeah, greater. What do you call the bottom one? Subtrahend?
The denominator.
Huh? The bottom number. If it's bigger, it's just like when you're doing regular arithmetic, you know, you got to borrow from the left. Instead of 10s, you're going to borrow 12s. So instead of 24 3, you'll have 23 12 and 3, or 23 15. That'll give you enough to subtract that. Okay. So if this is if you don't quite have this, you know, just fool around with this at home. Try to get, so that's simple. Probably most of you do. Okay, so there's a couple pages of exercise. That's why I wanted people to have the rules, because it helps. So, but it's laid out really horribly. So on the page 7, the bottom, we'll take a break after this. And we'll go to training stuff.
I didn't have to go really bad.
Yeah, no, and I wasn't talking to you. It just reminded me. We need a break. Hey, get back in the seat. I'm not done. No, you hold it for the whole class.
That's a dangerous
Okay.
game.
So the first one after the examples is 3/4 inch equals 1 foot 0. What's that?
PTSD.
What do you mean, what's that?
3/4 inch equals 1 foot. What is that designation called?
Run the 7 still?
The scale or?
The scale.
Yeah, okay.
Yeah. So if I ask you what was the scale in that line, it's 3 foot. It's 3/4 inch equals 1 foot.
Uh-huh.
Just vocabulary. Just getting you guys to get the vocabulary down. So then we find a 3/4 inch scale. It's going to be a lefty. And then we put 0. Remember the zeros after all the little tick marks. It's actually starting the scale. You put the 0 on the left of the line, and then you go to where it says right answer here. No. See, this thing is so confusing. Every year my students say, what the hell? You're not actually measuring that line, are you? There you are. Are you sure that's not where the answer goes?
No, it says measure this line. It has an arrow.
pointed to the line.
Oh, the line above. And the thing below is that's a long thing below is the answer, right?
Yeah.
Confusing me every time. Okay, so go to the line above the 3/4 inch equals a foot, where it says measure this line. And put the 0 on the left. Now remember, it's kind of important that you get it as close as you can see. And then the right, so we're using the bottom scale, because that's the one that's going up. So we go 1, 2, so it's past 3, but not quite 4, right? It's going to be 3 foot something, right? So then slide, what are we doing? Oh yeah, slide it to the 3, slide the 3 to the right-hand point. And then I'll give you the extra inches, and I get
4.5.
I get 4.
3 foot 4.5. Right? No,
Hold
maybe.
on. So the first line, so it's 4 sections, so they're each 3 inches, right?
Yeah.
Yes. So it's past the first one, so it's at least 3 inches. And then the second set of lines is an inch?
An inch.
Yes, an inch. So that makes 4, and it's a little bit past that, do you think?
I think.
Okay, so that 3'4", then a quarter? Something like that?
Or a half. So it's gonna be somewhere there, right? Either
Yeah,
quarter or
or a half, yeah. 3'4.5" or a quarter somewhere. That's as good as we can get with what we got. Okay, so let's do the next one, 1.5. Sounds great, huh? Okay, and that's from the left too. And that one, they don't, this isn't laid out well. I don't like it. So put the 0 on it, and then we go to the right, and it doesn't reach, I guess that would be 5, right? Now this is tricky, because all these numbers on the two scales happen to be similar kind of numbers. So this one's very confusing. So it's going from left to right. So the 0, it can't go to 2 on the bottom, the first 2, because there's no 1 mark. Even if the 1 didn't have a 1 by it, it would have to show a mark, right? So that first 2's on the scale, the other scale. So we go to the second 2, and that's the 2 for that one, which means that first 2 was what?
For the 3.
No, the first 2.
This first 2 right here.
No, the first number 2.
Right.
We are confused.
This,
You're
Okay.
confused. The two with the
well,
longer line.
okay, are you at the right
Yes.
place? Okay, so you got your 0 on the left of the line, right?
Yes.
And then we're trying to count up the red, but the scales are confusing because they've got 2 2s in
Yeah,
a row.
okay.
But what I was saying was, it can't be the first 2 because the 1, even if they don't write a 1, there'll always be a mark. And there's no mark there. So that must be from the other scale.
On the other side.
Okay, okay. You can tell from the 0 to the first 2 is approximately 1.5 inches, which is the scale that you're working with.
Yeah,
If-
that's another way that's a great way to collaborate. Is it's an 1.5 inch scale, so the 1's gonna be at 1.5 inches, which is about that first 2. Okay. And then we also know because the second 2 makes the first 1, so, okay. So we got, so it's the short, it's the higher scale, I guess you'd say, right?
So it's actually
So it's 4,
gonna be the second 2. Because
Right.
if 1.5 inches
yeah,
is a foot, the first one is too close to be 2 feet.
yes.
Yes.
Right, exactly. So we got that, so it's the higher one, it's got a shorter line to the top.
Yeah.
So before would be the next one. I mean, the 3 is where the 1 is, but we can go all the way to the 4. It doesn't go to a mark past that, so we know it's 4 something. That much we know. So then what do we do?
Slide.
Yeah, we slide it so the 4 is on that point, that end point. And then we're gonna go back to the left and read how many tick marks past the 0 it is going back. And then we gotta remember how many each, we haven't used a scale before, right? So we gotta know how many each one means.
It's a quarter.
Yeah, it's a quarter each.
A quarter inch?
A quarter each.
Let's see, hold on. So you've got 1 inch. Yeah, got it. Quarter inch for each tick. So this would be 3, 4, 4.5.
Yeah.
Around 4.5. Is that, do people get that? Okay, so who's lost? I don't care. Say when you're lost. Anybody?
All right, that is, yeah.
Okay, so,
We have a last one.
yeah, okay, so the first thing is to put the 0 on the left, right?
Yes.
Because you're starting with a scale, it's on the left, starts on the left. If you were a right-hand scale, you do the opposite. So you put the 0 there, and then we're just gonna find out approximately where that endpoint is. So that's what we've been trying to figure out, what those numbers mean, because they're all similar, they're low similar numbers.
Yeah.
This is probably the most confusing part of any of the scales. So we figured the first one couldn't be the 2 for that scale because there's no 1 mark, and they always mark every foot. So it must be the second 2 must be 2, which would make that first 2 1. Okay, so 1, 2, and then the 1 would be 3, right? The following one would mark 3, even though it says 1.
Yes.
And then the 4 would be 4.
Yes.
So we know it's at least 4, and then it's somewhere between, well, we just know it's not up to 5, it's somewhere between 4 and 5, or we'd see a mark, another mark. So we know it's 4 foot something.
Okay.
So then you take the 4, once you establish the lower foot number.
Oh, I get it, Patrick. I was in the wrong line.
Okay,
My bad. I was going to do this.
no,
line.
I told you these,
I
this is,
think I'm doing the wrong one
you
too.
would think, 12 years I would have.
All right, so
Fix
okay,
it.
I get it now. yeah. I was doing the wrong line.
The small.
Alright,
You would think, I would think, but every time I swear I'm gonna fix it, I go home and my
I was
house
like,
is burning
where
down.
did they get these numbers
The field
from,
next
man?
door. what
I
the
got
hell?
7.5 inches.
Goes right out my.
All right, we're good.
Okay,
Gotcha.
I know, this thing's awful. Why don't I just change it?
Gotcha. The long run.
No, this is
I was
the-
just like, I was completely lost.
Gives you something to talk about.
Right.
You know, but don't you find that in everything, stuff poorly written, like directions to put stuff together?
Just make the lines in Sharpie and then put.
Duh, right? Just distinguish the 2 lines. How hard is that? I know. Okay. I think you guys got the gist of that though, right?
Yes.
Okay. And if you're got it, but you're hazy, just do the rest of those at home. And see what, actually do them, write it down, and then we'll cross check if anybody does it and they want to check. I'll have something and we'll compare answers. That's a good way to do it. Okay, then the bottom is drawing lines. Let's not do that because it's the same thing, right? Okay, let's do one. What the hell? So the first one is, now see, they have this, no, it's the same. The scale's below the line. I guess that's the same. Okay. So this one, you're gonna measure from the tip of that arrow, right? They're throwing an arrow in there.
Right.
We're on page 8,
Okay.
the next page. Instead of reading them, we're gonna draw them. So, and so I can't tell if you've done it right. So the first one, it's a 1/4 inch. So the first thing we do is go to that scale, obviously. Now, we don't have a right thing to, we don't have a right end to it. It just goes into space. Right? I mean, we're not measuring anything, we're drawing it, right?
Right.
That's the difference. So, but it's the same principle. If it says to draw 12 foot 8, we're gonna draw 12 foot and then we're gonna add 8 inches to it, right? So we just figure out how to do that. So it happens, you can do it all in one motion. You just put the 12 at the end of the arrow. Right? And then you go down to the 0, that's 12 even. And then you just go 8, whatever number of ticks makes 8 inches. And we had said before that the 3rd tick is 9 inches. So it's the 3rd long tick. How can we say that? If you have different lengths lines in the tick zone, what do we say? Long, shorter.
Longest one's a half, the next longest is a 1/4.
Yeah, okay. So it looks like we want 8 inches, so we'd go to either 6 or 9, go to 9 and come back 1, or go to 6 and go up 2. And that's hard for me to see.
8 would be 3/4 of,
Yeah, but it's not measured that way. Yeah, if they had 4, if they divided into 4, it would be
if
that.
you 12 inches, 8 is
That's what I-
3/4.
Right.
Actually, that's 2/3, I'm sorry.
Yeah.
9 is 3/4.
Yeah, okay. So, yeah, don't confuse it, though, even though you might be right. Yeah, so you go from 12 on the left to the 0. That's, we're not gonna stop there. We're gonna note that, okay, that's for the 12 in. Then we got 12 with 8, and then we got 8 ticks to the right.
Wait, so what's gonna be right on the test, your way or the right way?
I'll prep you for it. Okay. But that's gonna be the tip of your arrowhead. Remember, you're doing an arrowhead. Okay, one more, because these are all the same. So you do them at home if you want to. So we go to 8, left side, go to the 0. Now, okay, here's a great one. Left side is different. It's harder. You can't do it in one motion. Wouldn't you know it? So you put the 0, you always put the 0 on the left, right? But you can't do it in one motion because you got to slide it. So you go to 20, you mark the 23, the whole feet, right? Everybody doing that, or? So the 1/8 inch scale's busy. So there's a 0 at the tip of the arrow. And then we want 23. So where the heck is that? It's the upper scale because it's going up. And it's, I see a 20, and I see a 24, 1, 2, 3. So each line's one, so 23 would be one to the left of 24, probably. Everybody see that? We want 23, so you gotta do the 23 first. So there's a 24, and if you go one to the left of that, shy of that, that's 23. So mark that. And then you've got to slide your rule over and add the ticks to that. When you do from the left, it's not as handy. So that's just 6 inches. So actually, no, you can't because those aren't divided.
Can I see your paper to see how, like, what I'm doing this right?
Can you what?
Can I come up?
Yeah, yeah, oh, sure, sure. Yeah, you can always come up or I'll come to your seat, always. So we're doing this one, right? I mean, first you gotta figure out what the heck line you're doing. Oh, no. No, we're doing that one, but it doesn't matter. I'll start here. So you're gonna put the 0 on the tip of the arrow, right?
Okay, we're actually working on that.
Yeah, are you, okay? That's all you need?
Yeah, I thought we were just making our own.
Oh, okay. Well, we are. We're gonna make our endpoint ourselves, but we're using that line to get,
Okay.
yeah.
I don't know.
Yeah, okay. So we're making our own length, but they've given us a line to draw on. So we'll just, some point we'll make a mark and put an arrow to it. So, yeah.
The correct location, if you use your regular inch ruler, should be like 2 15/16.
I think it's smart. Probably, I don't know. I'm still, so
Okay.
does everybody find the 23, obviously? So you gotta mark that, and then you gotta slide your rule over to that and measure. It's only half, right? Half a foot. That's pretty easy.
2 and 5/16. You said?
2 15/16. Once
I
you,
got that.
Oh, no.
yeah.
Oh, no. I'm mixing them up. Where are we?
1/8.
Are we doing the 8th?
Yeah,
Yeah.
I'm ahead, sorry.
That's okay. We're doing the 8th, right?
Yeah.
Okay, I've got that. Okay, so that's 23/6. So go over 23, which is one before the 24. And then we're gonna add 6 inches of that, but since there's no marks between the feet, we gotta find it, go to our tick scale and find the center of that, and that's 6 inches. Yeah. And then that's the tip of your arrowhead. So then go back to the left of your arrow. Yeah, we'd already done that one above, right? Yeah. So how we doing? Pretty good. Was that one okay, easy to do or doable?
We used the regular ruler to check each other, and we came up with 2 15/16.
Oh, okay, okay.
Once we made it.
Yeah, you know what's interesting? That's another point too. There's a million points, but but sometimes when you're drawing something and you want to center the graphic on this page, instead of doing scale, you can just do a regular ruler and just do it 3 inches from both sides or whatever. So if it doesn't involve using a measurement on the scale, use a ruler. It's easier to manipulate. And you can also, like they did, if you're comparing, you can cross-check by just measuring with your ruler and comparing that. So that's why the ruler's there. It's to get, if you have a fast measurement that isn't concerned with the scale, it's just to center something, then use the ruler because we're all used to that. Try what that's for. Okay, let's do the last one, the 3/4, yeah? I'm a line off. I don't care. It doesn't matter. So. Oh, God. After the weekend I've had, I'm amazed I'm still coherent. Okay. So got the 3/4 scale, it's the left one.
Tell us more about this.
But I will, it's really fascinating.
Yeah.
I found out more about this guy. I can talk to you. You'll never know him. But he was always weird. He was a student of mine here. That's how we got to know each other. And then he would be working on his house, not too far from here, and I'd come over and help him, and then we got to know each other. But he's always been really critical and not filtering anything, just says the worst things all the time. Some people do that. You just tell them to stop acting like an asshole. You know? So I find out, I knew there was, I didn't know what it was. So I'm getting, and he says, oh, did you know I'm autistic? And I said, no, you've never mentioned that. I've known him for like 10 years. For all the time I've known you, you've never said that. He said, yeah. And he said, and then he's an alcoholic. That's why I went to help him, because he was on his way out. And he said, yeah, so he's autistic and he's an alcoholic and he has insomnia. And last night he was explaining that to me. Does anybody have in here ever had insomnia where you cannot sleep at all the whole night for maybe several nights? Have you had that?
Yeah.
It's awful, isn't it? I've never had it, but he said of all the things that he ails, that's the one he fears the most. And I said, well, God, is there anything you can take for that? Because remember Michael Jackson?
Yeah.
He had trouble sleeping. That's why he's taking fentanyl. So they use that. But that's such a unpredictable drug. A lot of guys have died from that. Prince and what's his name? Tom Petty. It's just not, it's so strong. It's just not, you can't be careful on that. You know?
And millions of
But
other
a
people.
lot of those guys did it for sleep. He says, it's interesting because I had never known anyone or been that way myself. And he says, oh my God, it's the worst thing you could ever go through. So he has that too. And then I asked him, we were talking and I said, do you drink? Is that why you drink for your depression? Because we were talking about depression. He goes, and he pauses. Like I would think that he would just go, well, what do you think? And he says, well, let me think about that. And I'm thinking this guy's had this stuff for years and he's never even put those together. Oh boy. And he said, yeah. And you know.
Now, sorry, is this the prospect teacher?
No.
No, okay.
Great question. Great question.
We
Good
had to go to
question.
Silver
Let's talk
Rock
about
for the
him.
fall semester.
Yeah, what you guys are in for. But anybody here an alcoholic that would admit it?
I'm a
My
smokeaholic.
dad's an alcoholic.
Okay. But I don't know much about it. It's not one of my addictions. But and I'm Irish too. I don't know if I figure it out. I can break it, give it up for a month. You know? But anyway, he was really he's bought this land up in the mountains and he spent a lot of money having it plowed and gotten in the right shape, you know. And then he had everything it's in dope growing country, so it's nothing safe. So he had everything that he valued in his car. And he was coming back a week ago and his car caught on fire. I still don't know how, and burnt completely. Everything, $4,000, tools, mementos, because it was the only safe place. We had everything in there. And then he got to town and come back.
That's where I had it.
So he started drinking again. He's gotten off it, but that would be enough. And he was in shock. He called me. He didn't know he was in shock. I said, that's pretty bad. You know, so he talked. And then he was okay. And then he calls me Saturday. He says, I'm in bed. He's never asked me or talked this way. He said, I'm in really bad shape. So what am I going to do, right? So he's gone through this before. So he does I forget what they call it, but he goes off it by dosing, diminished doses. Because if you go
Microdosing.
cold turkey, you can die. It's that bad.
Microdosing.
Microdose. So he wanted me to help him microdose. So he had me buy this giant bottle of tequila on the way in. And I don't know enough about it, so I'm going, God, is this the right thing? But I figured I could talk to him when I got there.
Were you drinking with him?
No.
You went out there to drink with him, right?
No, but he was dosing big jiggers, you know. I thought, how's this gonna help? And first every half hour and then every 45 minutes. So I had to do, so I'm his nurse for this whole time, because I write it down. I never had any contact with that before. I just did what I had to do, but. And then he was so out of it because he was still high. And we couldn't have a conversation. He would just go off and he's autistic, so he goes off anyway. Anything, any new concept, he's off on that. I'm just shit. Trying to make sense of it. But, and then halfway through, Saturday said, I don't think this is working. Then he throws up 8 times. Like he's on his bed, he's just, and I'm going, oh, fuck. He's dying of
Now we gotta start all over again.
liquor toxicity. And then he sits up and he vomits more all over him. And then I go, okay, well, you gotta get in, take a shower, and I'll clean your bed. He says, I'm not taking a shower. I said, I'm not staying here because when we sit together, his feet are all over me. And then I go, I'm not sitting near you if you don't clean up. So I have to force him to take a shower. And I take his clothes, I'm washing his clothes and drying them in the sun. Ah, God.
Wow.
So he said, I don't know if it'll work either. I've done this before. It has worked. You know, I know a little bit about it, so let's hope. So I said, well, okay, I trust you. He's a pretty bright guy. I said, okay, what do we got to go by? You know? I said, isn't there a doctor you can call to check this stuff? And he said, no, you can't trust him, blah, blah, blah. So last night he was better. And this morning he was great. He was coherent. And he said, and he had a little bit left. He's down to real small amounts. And he said, you can go. I'm fine. Trust me.
This morning.
This morning. Oh, gosh. I told him when I got there, I said, I've got to go to bed by 11, because the last time I went up, we talked till like 3 in the morning. Get up.
Last time.
He said, we got to go to bed 11, and I got to leave at 8 to get to my class, to get ready for my class Monday. So he knew the ground rules. I was just praying that he was okay. And he was okay. And he's called me since, and he seems like he might be okay. So, but it's 5 hours there. I can't, you know, I've got some long talks to have with him about. Not depending on me, because I ain't gonna make that trip that often.
5 hours.
But he's never, you know, never dealt with his autism. I said, they must know something about autism. They have a medicine or something you can do, right?
I guess.
One would think. There's a lot of autistic people.
There's a lot of ads now. They're like,
Yeah. So,
I have autism.
you know, so I'm gonna do some research and make him do something, because
But it seems he is stubborn and lost faith on doctors. I mean, the way he's telling you, oh, they're,
yeah.
when you ask him, hey, is there, why don't we call a doctor? Is there-
He said they don't know anything about it. I said, well, how about I said, if you're not better, I'll take you Monday into town. It's an hour in town. And we'll try to find a rehab to go to. That'll take your dog, because he won't separate from his dog. And he said, okay. And then, but then later on, we're talking, I said, well, the rehabs probably have doctors or access to doctors, right? Because those people can have all kinds of problems when they're rehabbing. And he said, I don't trust them. I went to the place and
You just go into like Eastern medicine.
yeah, maybe. But he's got to do more. He's in shock from the car, you know, all his possessions. I understand that, you know, and he started drinking again. It all makes okay sense, but he's isolated up there. I can't go up there. So I'm gonna, when he's better, I'm gonna talk to him about doing more things, be more proactive. I don't know what to do with autism. Anybody see the Rain Man, the movie?
Yeah.
Remember how Dustin Hoffman would repeat things like 5 or 6 times? That's what he does. He goes, I cooked him up some chicken. He goes, Patrick, this chicken's so goddamn good. Patrick, this chicken's so good. 20 times.
Wait, what's that movie about Leonardo DiCaprio? His very first
Oh, yeah,
movie?
yeah,
That one I felt portrayed it perfectly.
yeah, yeah. But this Rain Man, I mean, it's exactly what Dustin Hoffman said.
What's that one where he also, where he was with Johnny Depp?
Yeah.
Yeah,
Gilbert,
yeah, Gilbert Grape.
yeah,
Uh-huh.
yeah.
Oh,
Yeah,
so good.
so, you know, when you first get exposed to this stuff, it's like I had to be on my toes the whole time, just to try to reason out what wouldn't kill him.
You should have took him to the casino and had him count cards for you.
I know, really. He had this stuff for sleeping. He said, this is the only, it's a Razapam or something. He said, this is the only stuff that works.
Have you
He
tried
said, but if you
Benadryl?
take it, huh?
Have you tried Benadryl?
No, not for that kind of,
Okay.
I take Benadryl
Make
when I
sense,
can't sleep, but.
Yeah.
But he said, if you take this when you're drinking though, it'll kill you instantly. I said, yeah, keep that way over here, okay? And he said, yeah, I know the difference. I'll be okay. God, complicated stuff, huh?
Good thing he doesn't have any depression.
Yeah, really. Well, I asked him if he wanted to live. At one point, he was just being so resistant. I said, God damn it, do you want to live, even live? And he started talking. I said, no, answer me. And I was yelling at him. I said, do you want to live? And he finally broke down and said, yeah, of course. So I said, okay, that's step one. I said, then we'll have to figure this out. And you have to listen to me too, because I know some things about staying home.
I probably didn't get the introduction, but he's a friend of yours.
Yeah, he was a student here years ago. And he lives near the school and I used to help him with it. He remodeled his house and I'd go over and help. He'd ask for advice. And I'd go over and help him. We became friends. Not close friends, but you know, I'd see him every once in a while.
Did you ever ask Rodney for advice?
No, I will. I will now. I had no reason to, but I don't know. I mean, I asked him, I said, don't you have AA friends that you can call? And he said, yeah, but that's mostly for emotional support. They don't always know medical things and, you know, what to do, right? So I said, well, damn, you gotta find, you know, you gotta find someone who can give you the medical stuff.
Detox.
Yeah. So we'll see where it goes. Temecula is a big city, so it's bigger than Santa Barbara, so there ought to be something there. And this dog almost got burnt in the car, so he's traumatized. That was a big thing. He didn't care about the possession of the dog. You guys want to hear that?
Sorry.
Well, that's why I'm a little dingy tonight.
If he's anti-traditional therapy and stuff, there's some great new therapies out there.
Well,
There are
Yeah.
practices.
he's done a ton of therapy in his life, very new age type stuff.
Okay, no, yeah, there's some great like psychedelic therapies. That
Yeah.
are becoming
I don't know if he said that, but he's
Yeah, like
every time I
ketamine
see him, he
treatment.
just finished some workshop. Somewhere. But you know, a lot of that stuff's not deep enough or not quite right, you know, it's.
You
All
should really
medicine,
check it out.
West,
Check out
East.
Rhythmia.
Yeah, it depends on the group and the person, you know.
Right.
Totally, so,
Yeah, you need a good guide.
but. Yeah, so,
So some of it has been proven to help people with
Depression.
alcoholism,
yeah,
certain things.
well, you know, he has doctor friends that, I don't even know if they're real doctors, but they're medically savvy people that do some kind of either full medicine or pseudo that when he gets like sprains or something, he'll call in for that. And I thought, geez, I should know somebody.
Yeah.
Because we know, you know, all that stuff's known, you know, especially the toxicity. He doesn't have to. The rehab, how you get, that's different, you know, but the medical stuff, you know, probably pretty understood. Okay, let's take a break and we'll come back.
Okay.
And then we'll do, we'll keep doing this each time, just a little refresher to make sure, for sure everybody's got it. And then we'll do the framing and the overview. Some of you frame, Eric, my God, it's framed so much, but a lot of you have framed some. And so we'll just go over it. And some of you are new, so we'll go over that. And the new people will have to take the thing home and probably look at it a little more. You don't need to know everything, but we'll be looking at framing plans, so it kind of helps to know the nuts and bolts, a little bit of nuts and bolts. So we'll do that after the break. So 8 o'clock.
Yeah. All right.
Night's still
You
young.
got any more chicken?
I'm vegetarian. I'm cooking this guy.
Wanna hear more about
Chicken. Chicken.
You're
Boy,
vegetarian?
he loved that. Yeah. He loved that shit. Got it from Costco.
Probably had an eighth a week.
Well, that's it. He was emaciated.
Yeah.
And so I made him eat. I had him make him eat too, and they didn't go together. But if he drank and then he ate, he would instantly fall asleep. And then he couldn't make the next schedule.
Phenomenon of craving, like once that alcohol hits it,
Yeah,
there you know.
Yeah.
Nothing else matters.
I know. And so, you know, that was what I was up against. I was trying to get food in him, you know. I had some yogurt and a banana. I said, well, how about, you know, if they threw up without the yogurt, my food. And I said, don't give me that sissy food. I said, fine, I'll eat it. He didn't offer me any food and I didn't take enough, so I was so starved today.
Hard to help people like that.
Huh?
hard to help people with that.
Yeah.
If you can even really help them at all.
Yeah, that's the being bad endpoint. We'll probably find that out.
Yeah.
But I'm gonna challenge him. I mean, I yelled at him and Noriko, when I went up, she said, well, Patrick, don't get angry with them, argue with them. I said, oh, I'll try not to. We're both shouters, so that worked out good. But, he's just got so much going on. Jesus.
Yeah.
And he's all alone. He's got his dog though. Dogs just make the difference,
Definitely.
And he's saying if he didn't get a girlfriend before his dog died, that he'd just kill himself after his dog.
Oh my gosh.
That's how it's a service dog,
Yeah.
and it's, really been necessary for his life.
And that guy should just get another dog.
Well, that's what I said. I said, you can just get a frickin' another dog,
Yeah.
and no one will replace him.
Okay.
I said, yeah. But, really. He's a good guy. He's smart. He's done a lot of work. He's worked at health food stores and Omega, that new age place, that gives, I think it's called Omega, that gives workshops and stuff. So he's done, and he's been a physical therapist and a massage therapist, so he's done a lot of stuff. So he knows a lot about health. But you can still be biased, when you know that stuff. But and he's an outstanding musician. He plays piano, and I used to go up and listen to him when he lived up here. He had a baby grand, and he just could play like, whew. And he sings, and he had Nork and I invite us to a choral group he belonged to, and they sang at the Music Academy of the West. Talented guy, really talented.
Yeah.
But I think he can't help himself. But now that I see that he's autistic, he probably really needs some professional help in that direction.
Yeah, there was a guy in my cell bio lab this last semester. And he had some sort of autism, and it was sad because everybody could tell, that he had an issue, but he was in denial about
Yeah.
it.
Yeah.
So I think it's got to be hard. Like I could never imagine having some sort of.
He calls them go-arounds, I think. To go around so you blend in or don't get caught or whatever.
Right.
So yeah, he says my whole life's made up of that.
Huh.
And then he was telling me his past with his dad. His mom died early and he had a really abusive dad.
Yeah, that's rough.
Humans are so fragile, We think we're so tough.
Yeah. All in disguise.
Are you in the middle of a conversation?
No,
I have a question and a note from admissions for you.
Yeah.
The note from admissions is, so when I got there to turn in my paper.
yeah. I was so glad to see your name on the roster. I said, I don't know how he did it, but he did it, but there's a hitch.
Oh, okay. So the guy, so I rang the bell and he comes. He's probably 6-7 feet away walking towards me. Are you from construction technology? And I said, yes. You're like the fourth or third guy that is here today. So that's when I knew I had to, be empathetic with him because I wasn't going to, take it personal. Oh, I am so sorry. This is a good time to be here. I can just come back some other time. Well, anyway,
You're so smart. That's how you deal with bureaucrats, totally. You throw the power back to them. Hey,
Right,
you're in
right.
charge. Tell me what to do.
Anyway, the message is, tell your teacher that this can be done online. There's no reason for you guys to be here. You can fill this out online. So I don't know.
You know what the problem with that school is? Everybody tells you something different.
Yeah.
So I asked my chair and he checked it. He called them. So some counselor gave him the wrong number. information, and he gave me the wrong.
Oh, yeah, right, because we were here when he called me and left you a message or
Yeah,
something like
yeah,
that.
and he said, I'm sorry, they have to do it.
Right,
And so that happens all the time, different stories from different folks. So I'm just glad you guys. It didn't make sense. It doesn't make sense. Everything in 2022, we can't do everything by online.
the only thing that I thought of that it had to be in person is because it required my explanation and your authorization. So it
Or like
was,
if money's involved and they're gonna give you money back, you know, you wanna make sure it's the right person. Yeah, there's time for that. And so I try to think, I think, is this really, you know, is this one of those cases? And usually it's not.
Do you remember how?
Like this student, you know, the high school student?
Yeah.
He's in high school, so he has to do a whole bunch of other stuff. This guy right here, Anthony. And I forgot to ask him if he'd applied because not all of you are obviously already in the system, and I just didn't think about it. And then after he'd gone, there's only limited time. And so I called him and he didn't call me back, and I thought, oh, shit. So I called the guy that I work with in admissions, and he says, yeah, he'll need a parental consent if he's underage, and the high school counselor has to sign off. And he said, you better send those guys the forms right away. So I find the one form, and the form links on the school are old or ancient. They don't work half of it. The school never gets rid of its links. So I got the one form for the parent, no, for the school. And then the parent one, you had to do online. The parent had to do it. They wouldn't, I tried a million things. I couldn't get a form out of it. So then I called the dual enrollment people, because it's actually a dual enrollment student, which I didn't think. Because usually those are students where we have a teacher there at the high school. But if any high school kid takes a thing here, it's also considered dual enrollment, which I might have known back when I was chair, but I forgot. And so I couldn't get a hold of dual enrollment people because they're understaffed because of the COVID and all. So, you know, and there was no way, there was no number or website that, you know, I was just going nuts. I was spending like hours on it.
right, right.
And so finally I get a woman there, Mike Ganell says, oh, they have an online on Thursday, has to be Thursday from 11 to 1. So you can just go and get information. So it was 12. So I go and it doesn't answer. It goes, this meeting person will be with you in a bit. And I waited like half an hour. In the meantime, I'm going to her superior and all these people, and all you can do is leave messages. And so finally, she comes on the screen. I almost missed it. And she was great. She was pretty. I complained first, and she took it. That's what bureaucrats need to learn how to do. It's just not fan the anger, you know?
Right.
Oh, yeah, I know, yeah, you're right, you know. And so finally, she said, she looked up and says, hey, this guy's got all this stuff in.
This guy what?
This student has all this stuff already turned in.
Oh.
So I did all that for nothing. And I said, well, I still got the thing I gave you, that you got,
Uh-huh.
And she said, oh, you can just, so what I did, she didn't say what I had to do that. So what I did is I just scanned that and emailed it to Akil, the guy, and then said, Akil, you don't know what I've been through, but there doesn't seem to be any reason why I have to come, he has to come down and bring this. So here it is. And then the next thing I knew, he signed off and he was on my roll.
Okay.
But I spent about 3 hours on it. I was so pissed.
Of course. Of course.
I mean, 3 hours is 3 hours. But I've complained, it's not just a school. Any business that's even a fourth that size is already big enough that they're going to make tons of mistakes like that. They just don't seem to be able to, get it right.
So how many
You know,
people?
what they ought to do is, if somebody really wants to help them make it right, no matter what their background, they should hire them. I would go for a year and do all the systems there if they paid me my regular salary, and I would make everything, all the websites make sense. I would just do that. Why don't they do that with someone that knows what they're doing? I mean, I'm good because they get computer people and they don't know what it's like to be a layman trying to do something because they have all these tricks to do it. So they're not good quality control people. You need some dumb old guy like me that didn't grow up in computers to come in and say, this doesn't make sense, That's how they would learn.
Okay.
And I would volunteer my services. I'd love to do that. Because I'm just stupid enough, I'd be perfect, And I'd let them know when they were wrong too. I'd be pissed off.
So Patrick, how many people did we end up with in the class?
Well,
If you take.
Memphis, remember Memphis?
Yeah, if you take the people that you draw.
I got 15, and Memphis will make 16, but he emailed me and said he was out of town, and could I give him the link to the thing, but he's not on my roll yet. So I emailed back, said, yeah, I think I sent him the link, but some people lose it. So I sent him the link and I said, he said, can you give me what do you call the code,
Add code,
ad code?
but you already.
And I said, didn't I give you a slip the other night with all the other guys?
I lost it.
He said, I'm out of town. Can you just send me the passcode and I'll do it? And I said, no. Remember I gave you that, what do we call
The
it?
form, the paper.
Yeah, what's it called? Late ad petition or something.
Mhm.
Yeah. And they write back and says, yeah, I turned that in. He was one of those guys who turned it
Okay,
in,
yeah, before.
but he's not on my roll. So, and he's not in pipeline, so I don't have his K number. So I emailed him back, said, if you send me your K number, I will talk to my guy in admissions and see what's going on. So I'm waiting for his K number. And, he was probably going out of town to work. Well, he did what he was supposed to do. So I don't know. You always get a little bit of this at the beginning of class, so. It's when you get paid the big bucks for, Unless you're an adjunct, and then you get paid little bucks for doing it. So I really like the new guy. I had a long talk with him today. That's good. He's excited. I said the deans count on you to reform the program.
No pressure.
I said, no, but I'll be around to help. I said, no, but you got a lot of new skills, different skills and ideas, so we'll go for it.
It's so funny that my boss, his brother, is
Yeah.
leaving the company in August. And he's coming in to here in August, so I'm like, I'm just trading one poverty.
Yeah, really.
Wait, your boss is the one that's gonna be.
No, my boss is the brother of the new guy.
Yeah. So, yeah, and is it his company?
No,
It's his father, the father's company, right?
his dad does own a company, but Sam doesn't work for that company, he works for David Chase.
Oh, okay. That's right. But Timmy, the guy who's coming, has worked for his dad, and I think he might have worked with his brother too. Which is good, because I wanted to make sure he had framing experience, and that's what he did there, so. He's got if you're a woodshop teacher, you've got plenty of finished experience, because that's all they do. All that work's finished work. So I was glad he had framing background.
Woodshop did not prepare me for construction at all. The only thing it taught me to do was read a tape measure. That's
Yeah.
enough, but like,
In which class?
SM Woodshop. When I went to San Marcos
Yeah, but
with Justin.
you didn't, but were you, doesn't he have a subclass that's
He does.
CT? Were you in that?
I was in that. I learned, the basic woodshop did not prepare me at all.
Yeah,
Learning how to use a speed square, read a tape measure, all the quick things.
they would complain, the high school teachers and the counselors here, and said, you gotta, the dual enrollment. First, I didn't give them credit for one of my classes, because I knew they couldn't do it.
Mhm.
I knew the setup they had, just like you're describing, and I said, how is that fair to everyone else, and how does that prepare them if they miss all that? Like if they miss 110 because they took whatever they took.
Mhm.
And finally, I had to give in because they just said, look, if there's no incentive, they won't, it's not good. So I said, fuck it, give them credit. What are you gonna do? And hopefully the other classes will be enough.
Yeah.
But, I mean, I'm not against making it easy for them, but I knew it couldn't be the same class. Because
Yeah.
I had a guy in Carpinteria High, great guy. And, but they, down there, they had, the construction was part of metal shop and tractor refurbishing. Because it's an ag community, so they fix up tractors. And I said, fine, I go down there and I go, we want them to take a wood shop, and they used the text, and I said, fine, let them do tractors and this, and whatever. If the authorities here knew I was allowing that, but they wouldn't have anything.
I mean.
Plus, tractor refurbishing is a good thing to know when you're in carpentry.
Justin, nearing the the time when I left, started teaching us more about framing.
Yeah,
And focused on what
Yeah.
wall, how to construct it, 16 on center,
right.
all those things. And at the wood shop, show at Earl Warren, or all of the like activities shows at Earl Warren with DPS on the
Right.
SB. We just built a wall and
You built mock stuff, right?
yeah.
Yeah.
We built a, we were passing a nail gun around really quick with a
Yeah,
bunch of
yeah,
two by
yeah.
fours, just built a wall, put it up
Yeah.
right in front of the thing.
You know, all you really want to do is just, when they get into the real building situation, they're not scared of everything. They go, yeah, I use the nail gun a little bit, I can figure this out. That's all you really want.
Yeah.
That's all, these are really good too, just so people aren't intimidated when they get on the job site. I mean, that's worth it, because sometimes it can be, you know, the wrong job, it can be hard, it can be really rough. But you weren't there when they did the tiny home, right?
I was there nearing the end of it.
Oh, yeah, because that was, you know, that was a lot.
Yeah.
That kind of work.
So I only did the finish work of the technical building.
So Don Gordon came and did the siding.
Yeah.
You remember him?
Yeah.
I worked for him once, and I was in an organization with trade art with him for years. He's a funny guy.
There was a day after school, Coach House saw my brother and I about to walk home from school. It's like, guys, I need your help putting some of the like side paneling on. We'll do it really quick, 1 hour. We were there until like 9:15 and we were like, great.
I thought I was the only one who underestimated time. I'm always thinking, oh, that wall I could, Eric told me does it right. I would say, yeah, I can do that in half an hour, and then 2 hours later, everything goes wrong. Yeah, that's an art, estimating time. My wife used to say, Patrick, estimate the best you can, then double it, it'll be right on. And she was totally right. It was always that way. You know, you always, because I'm kind of a speedy guy, so I always think I can picture the speed I go, so, but I can't build that fast. Okay, so let's look at this quickly. Right? This way.
Framing construction?
So, frame construction. And so on page 2, which is the back of the front side, there's it's a complicated, it's a floor, so basically a floor, second floor system with a garage underneath it, and it's part of the house, and crawl space, and it's on a hill, so it's got varying things underneath it, but that's a floor framing. So floors are, this is on the back side of the front page. So flooring systems, and probably other pictures, but so for framing, here's the essence. Engineers figured out how to support weight above a floor by the size of the studs and the spacing. And they also, as engineers, they realized that the spacing has to be even to support stuff evenly. So everything's that way. The floor system is joists of a certain spacing and a certain thickness running parallel, and they're connected on the end with a header. And walls are the same thing. They've got top plates and bottom plates, which are like the headers, and studs. And then ceilings are the same way again, and roofs are the same way again, only they're at an angle. But it's all uniformly spaced and rightly determined thickness of wood. That's what stick framing is. So if you keep that in mind, then everything kind of is parallel and makes sense. I mean, there's a lot of details after that, but that's the overview. So flooring, you know, that's kind of a complicated floor, but that's what it looks like. You can see the space joists. Well, it's a ceiling and a floor. But they're the same thing, right? Ceiling and a floor. And we'll look at foundations and what the floor rests on, because that's actually the first, but that isn't the way that I put the diagrams in. So we'll get to that. But the next page 3 is a typical wall. And that's important to note. I mean, obviously, you guys who've been working in framing know this pretty well.
We had this last semester.
Yeah.
This is a great reference.
But here's the rationale for why a wall is like it is. The thickness of the stud and the spacing, I said, was engineered a long time ago. And the type of wood matters too, right? some wood's more supportive than other woods. You get with Douglas fir and back east, they use spruce. It's very similar. They're kind of, are they a softwood or are they in between? Douglas fir.
Yeah.
Yeah, it's in between. But it's soft for a hardwood. Yeah. It's very, you can put your fingernails into it. But they've determined that density of wood at a 2x4, 2x6, 16 or 24 on center will support, the floor above. So we know they've got all that worked out a long time ago. But then you have openings, right? The weight comes from the second floor of the roof, however many floors it is, and they bear down on that top plate of the wall below. And then the studs, that weight just goes and distributes along all those studs. But if you break those studs, you take some of those studs out, like for a window or a door, you have to have an opening. Then you have to make up for that lost structure there. So the way they do it is they put headers in that distribute the weight to the side. And those headers are thickened, and they've all engineered this, so they know. So they know exactly the open length of the width of the opening of the door, how thick a header is appropriate. And so you have headers, and then sometimes the header is high enough, if the window or door is high enough that it can go right against the top plate. Other times, like in here, you have to put little cripple studs to make up for that difference. And then underneath a sill door, you just have that top because the bottom goes all the way to the ground. And then you'll see that there's a member on the door. There's a member that holds up that header. The header's nailed. The header's nailed from the side, but it also needs something underneath called a cripple. I mean, not a cripple, a trimmer. Sorry.
So it doesn't say.
The terms vary east coast to west coast and north south. There's some alternative, but trimmer. There's another. Do you know another?
Jack.
Jack. That was probably the older term, but in California it's been called trimmer a long time. So jack just means shortened in anything. A jackass is a small ass. Any kind of jack means just a reduced version. So all jack members are like a trimmer's shorter than a stud, so it's a jack. But I think in California, are any jobs now? Do you hear people call them jacks?
On the East Coast.
Yeah, but out here they call them trimmers, right? In your experience, yeah. East Coast there's some difference. Header I think's common. Double plate's common. Does anybody know there's two top plates, right? One bottom plate and then two top plates, and we call those are called different things. First top plate, second top plate, double top plate. What do you refer to them?
Double top plate.
Yeah. Whatever comes to mind, you can come up with a word that distinguishes them.
So
So
a
it's
lot
not,
of places will use double top plates everywhere, but technically you only need them on bearing walls.
yeah.
Like your partitions can get away with this.
Yeah, so we'll talk about that later. Advanced framing, they try to see what wood they can get rid of, and if it's not a bearing wall, it's going the opposite direction where the rafters are coming down or whatever. You can really reduce that quite a bit and not have full headers. And you can also get rid of trimmers, and you can use brackets that hold them, and you don't need a piece of wood. So you save that whole piece of wood there. So we'll talk about advanced framing. I think we have in our green building, but we'll go over it again a little bit. There's a sill, the bottom of the window is a sill. Usually the stud next to the trimmer, the last stud before the door, when it's called a king stud. And the reason they give it a name is because when you're laying it out, you can put a K and then a T, and you can tell where you are. If you just had X's like regular studs, you go, where, what's what? So they have symbols that really help you do stuff. And the symbols vary too, a little bit. But the walls and floor, all the systems, right, of members held together at the ends are spaced by center to center, is how they do it. And you'll see CC in where it's marked. That stands for center to center. But if you go to build a wall, here's the bottom plate. And if you mark a line at the center of the stud because they're center to center, and then you mark one 16 inches or 2 feet down here. When you put that stud on the line, you're covering up your line, so you don't really know where the stud goes. So what we've worked out is we draw a line, and that's one side of the stud. So when you're laying out, you draw a line, and you put an X to the right of it or to the left, but you know, there's certain conventions, but it could be either way. And then you put that, you cover that X and you put the edge of the stud right up next to the line. Then you can see the line. The line's at 90 degrees. You'd be surprised if you don't have it. They can be twisted. So that's, I mean, for all you guys that are framing, that's obvious, but when you first learn it, it's not obvious. You really have to know that. Some people I've noticed over the years will do this to avoid confusion. They'll put both sides of it, but the ones that are really in a hurry and that are experienced only do one because they don't want to draw that second line. Time is money, right?
We'll put the X.
Yeah, but sometimes if it's a new person, they want the junior member to get confused, or it's really a kind of a weird layout. And want to make sure those both lines. So, but what I was going to say is, so the center line is center to center. But if you look at this, there's 3 quarters on each side. Can't we just shift those over to the left? And wouldn't that be the same amount?
Mhm.
So when you lay out, you're laying out 16 or 24 on center, but you're laying out to the line on one side of the stud all the way across. So that's another thing that's, for some people, it's not intuitive. Why is center to center the same as left to left or right to right? But it is. And you just have to, that's how you lay out. So you just have to know that. This is just very basic. Now we have, I still can't have trouble, but we have thicker bottom plates now. And is that across the board or is that just thicker, like 3x4 bottom plates
On shear walls.
on shear walls?
Yeah.
But if you have a shear wall on one, say a corner of a wall, you probably have to do the whole wall that way, right?
Usually, yeah.
Yeah. So that, I left being in the field when that became a law. So I haven't actually framed with 3x. So I asked people what, you know.
So you
what
get
was
better
raised.
nailing.
Yeah. So the reason they have it now, it used to be 2x, same thing. Engineers rule this thing. We've had a lot of seismic earthquakes in California. I mean, not a lot, but well, we have a lot of little ones, but we've had some really major ones like Simi Valley and Northridge. Destroyed a lot of homes, killed people. The engineers jump right in there when that happens and they look at what happened, why the houses failed, why the earthquake pulled them up and moved them when they thought for sure they would be there forever. So we've learned a lot. And one of the things that came out of that were shear panels. So if we made the corners of the walls stronger, they couldn't rack this way. A lot of it was racking. You know, if you have a lot of parallel things and nothing to stop it, it'll just kind of go that way, right? And that's how a lot of collapse happens. So they said, well, we've got to secure one end so it can't do that. So they have shear panel, which has got extra ply in the plywood, extra nails, nailing patterns tighter. And there could be hold downs, which means ordinarily a wall is, or in the old days, or a slab, you have just bolts coming in, right? This is the slab here. Well, and the wall, this is concrete in here with these anchor bolts. And then the mud sill comes on top of that, well, or bottom plate. And say this was a, well, for this, the earthquakes would pull up, you know, we used to have, well, I guess they weren't even square. They used to be, the old nuts are like this, right? Octagon. Eric, is that right?
Hexagon.
Hexagon, okay. They used to be about, well, not even that size on the top of these. And a lot of pressure will just make that like a drill bit and just pull it right up through it. So the earthquakes were just pulling the walls and everything above them, which is the whole house, off the foundation. So they started making these bigger. You know how they're pretty good size, they're like that. Right?
The washer.
Yeah, the washer. Yeah, the washer. The nuts are the same, but the washer, the old washers used to be this big. and they were round, you know, they were just a little bit bigger than the nut. But those would just pull right out. So now they've got these, but say you have a raised foundation, not a slab. This was a slab, but say you have a foundation, and then it's got, this is all concrete, and then you've got a plate on here, because you have to start wood, because you're gonna connect things. You've got bolts that come up here, right? And they hold that, and you put and then you build your floor system on that. So you put joists running across, and you nail those into that, you know, nail them into that wood. Well, what's holding this plywood and this? What's holding this to the basement is you've nailed this bottom plate into the floor system. You can imagine how much those nails are going to hold when an earthquake comes. You're going to just pull this whole wall up. The floor system may be great because it's bolted. Well, it'll go too because it's only nailed into. The only thing that really is earthquake proof is this sill plate, this original mud sill. Everything above it's vulnerable to being pulled off. So I said, well, how do we connect the walls to the foundation? We can't just connect them to the floor. It won't do any good. So now they have these bolts that go all the way down into the foundation. So the wall's now connected to the concrete. And those usually go into a shear panel. So you have hold downs. Usually they put them together at the end or at a vulnerable spot in the middle of the wall. So all that's just from the earthquakes that we've had. And the engineers go in and say, yeah, it's just pulling those things right off the foundation. So how do we secure that? So they said, well, make a long bolt go all the way up to the floor system and into this bracket. And that bracket bolted and nailed the hell out of it too. So it really works. It works pretty well. Every earthquake's different, has different movement. And we built this one for the last two big ones, but the next big one may not have the same rhythm and may just make quick work of that too. So we do what we can, and then they'll go in and look at that and they go, oh, we didn't account for this motion.
The bolts too that go onto the hold down brackets actually go down 36 inches in the foot of the.
Right. And then they go, and then they can be connected to floors up above, right?
Sometimes, yes.
You've got threaded stuff so that it's the floors above are all connected to that foundation.
So is that code now that they have to go 36 inches into the concrete?
California.
Wow.
Doesn't
Because
go-
we were learning,
For hold downs.
okay, because we were
Not
learning.
all bolts, but hold down spots.
Okay, yeah, we were learning like, what is it, 10 inches or 8 inches has to be?
I think that's
James
regular, the regular bolts, the anchor bolts.
Yeah.
I don't know what to hold down. Eric could be right, I don't know. I tend to trust him. He's wrong.
Yeah. No, I was just saying,
Yeah.
like, maybe.
See, that's the kind of thing I'm
Jim
not in the
hasn't
field and that
updated
changes all the time. So
Yeah.
you just have to ask Jim or somebody who's still building what they wanted to do. Yeah. But anyway, that's what that's about. So you see that, you know, you don't have to sheathe a house. Back east, we sheathed. I worked 10 years in Maine and we sheathed all the time. And it wasn't because of seismic. They don't have as much seismic here. But they just realized it made the house stronger as a whole. So they just did it. And then I came here and at first they were just sheathing the strong, what do you call it? The strong walls, you know, what, you know, you know, the thicker plywood and the bigger nailing at the end. Yeah, what do we call that?
Shear,
Huh?
shear.
Shear, thank you. That's right, shear panel. So the shear panels, that was first done here. But then if you just do the corner, then the surface goes in where there's no shear panel, just studs. And then you've got to put strips along all the studs to match that. If you're gonna put stucco or anything. And that's a lot of work. You got to cut those little strips, you got to nail them on. So then they said, hell with it, we're just gonna shear the whole thing. And it does make the building stronger, obviously would have to. But I don't think it's totally necessary because you have those shear panels and all that. But that's the tradition now. So we just do the whole 9 yards. Costs more money too, but that's partly why houses cost more from decade to decade. Is also all the stuff we learned, our specialized hardware, members. Okay, so, oh, another thing is you have to have bracing, right? So it won't collapse that way. And before shear wall and sheathing, they used to do lead-in bracing. So they take a saw and they'd mark you have to have somebody, it has to cross so many bays of stuff. And then you snap lines and you cut in, you say your saw at 3/4 and you cut in, you knock all that out and then you put a 1x2. That's a lot of work, right? I mean, guys get really fast with it. And then they came up with metal, about 3/16 metal strips, and they could just be nailed on the outside and you had to kind of stucco over it. And, it wasn't great, but it was handier. And then people said, well, if we're doing that and we got to do shear panel in the corner, wouldn't it just be easier to, it would cost more plywood, but it would actually be pretty fast. So that's another reason they went that way. Because it just reminded me, they have the diagonal on this page 4. They show some diagonal bracing, which I don't think anybody does anymore. It's good to know about because when you're demolishing or deconstructing a house, sometimes that'll be in your way or it'll be causing it to stop. And so if you know about that, you can tell there's a brace here. Or you can cut it. You have to, if you're remodeling, and it may be the only thing that's creating shear, so you don't want to cut it completely. So it's good to know about it, even though they're not building that way. They used to build that way. Page 5, there's a floor or ceiling system. And same thing, when you have openings horizontally, like a chimney or a stairwell, you're not supporting the walls around it because you've got holes now. So you've got to beef up around it. You can see how they double and triple around the stairwell and that thing. So they use extra wood. So when that weight gets transferred around it, it's got more substance to bear. And there's when you learn to frame, there's specific ways to do those things and how to nail them.
I have a question.
Yeah,
So when you have, picture this structure,
yeah,
the one that we just saw on page 5,
yeah.
but it's just the ceiling joists, right? So they are not necessarily carrying any weight like from.
No, the wall, they'll be carrying the roof.
Yes, right.
Well, no, the plates on the side will be carrying the roof. Well, it depends on the roof. No, they don't carry, you're right, they don't carry the roof, not directly.
Right. Well, what I meant was that there's not a furniture on top or people walking on top. I'm talking about the ceiling joists, right?
Yeah.
Nothing that.
Yeah,
So,
well, that will depend on what kind of attic you have.
right.
So if you have an attic where you're gonna store stuff, and there might be weights involved, or you're gonna go up there and get stuff, then that will demand a slightly stronger joist plan. If it's an inactive attic totally, then you can minimize it some.
Now, based on that concept, that is gonna be not you, basically, there's just gonna be insulation of there and light fixtures and quick cabling and so forth. If you are going to modify a joist, let's say it's just one joist that you have to cut because there's a light fixture right there. It necessarily needs to be beefed up, like the ones on the side need to be doubled, and then like the one here for the stairwell, I can get it. For the
Yeah,
chimney, I get it because it's a floor framing
Yeah.
plan.
yeah.
But if it's like the ceiling and it's.
Well, let's put it this way, the inspector would make you do it. The permit would probably make you do it, because they really go by the book, but a lot of people would shortcut something like that. But if you had to cut it back, it's not a lot to just put a header across there and hold that. That's a simple solution.
Okay.
And even just one would probably be enough. And it also depends on where it is. If it's in the center of the room,
Mhm.
it's more vulnerable, but if it's toward the sides, there's a wall underneath close by, then, like there's one of these drawings and one of these books has 2 openings and one's near either a wall or a girder, and it's beefed up differently. And I always have to point it out to students and say, well, why is this way? And I'll say, well, it's right next to a girder, so it doesn't really need, but this, I don't know if this is it or not, but it's somewhere.
Okay.
And then page 6 is a roof. In fact, we do a roof like this in our roof framing class. You did that, right?
Uh-huh.
Kind of like this, that gable. Yeah, you did it too. has a gable and a hip.
Yeah, the one number 6, right?
Yeah,
Mhm.
yeah. And then, number 7 too, it's got a gable on the end, but you don't need to know the names. You will eventually, you should know the names of the different types of roofs, but. And if you're interested in that, this has some of those terms on it. And then this, sometimes roofs, we do a thing called a truss now. It's a factory-made roof component. And it's got the joist, ceiling joist and the rafter together, so you don't need the joist. You can just drywall the bottom of the truss. So it saves a lot of time. They're strong because they have webbing. They have diagonal pieces that have got a metal plate that holds it really well. And so you don't need to, you don't need to have thick enough wood to span a whole opening because it's being held up in the middle. So you can use, usually they're 2x4, occasionally 2x6 on the bottom, but most of the wood's all 2x4 because it's so bound together. So that saves, 2x4 is the smallest piece of wood you can get. So you can use small trees. You don't have to use big trees to get that. You know, the reason you use big trees is because there's knots in trees and wood has to have a minimum amount of knots. If it has too many knots, it's not structural. So for a really big 2x12, you have to get a pretty good sized tree to get to a place where, you know, you're going to have wood that's good enough. And so you end up cutting down a lot of old growth. So any scheme that allows you to use smaller dimension woods really much more sustainable. But trusses really do that. You know, there's arguments about which is faster, trussing or site building. I don't think there's an answer. You know, have you ever done roofs by what do you call it? When you go in and just do the roof and they pay you for that? What's that called?
Piecework.
Piecework, yeah. Have you ever done piecework roofs? Frank Skipper, you know, Skipper Construction, he was in that same class. I mean, that same thing with Don Gordon. Who was talking about Don Gordon? Somebody here. We were just talking. Oh, it came to the school. Yeah, it came into the siding at the school. So, and he did that when he was young. He's like 85. So you can imagine when he was 20, 65 years ago. That's all they did here. But you got, you know, they would sub out each stairwells and roofs, and they'd come in and they'd get a fixed price for a roof. So time is money. So they didn't know how to knock it off. Those guys, if Eric did it, then he's included in that. Those guys are really good because usually the roofs would be similar in the town. They're often similar, so you could at least, or if it's a development, they're all the same. But still, you
You
know,
got the same guys doing the same thing every
yeah,
day. So
you just assembly line it. But they crack them out. They have to do it, and they get really skilled at it. They're really good. But so they could compete against the truss because the truss you need a crane, usually, not always, but and then there's, you know, you can need a bunch of people to wheel it around, and you have to block, and you have to put temporary pieces on to keep them from falling apart, and then take those off later. So I'd say really fast on a simple roof could match a truss thing. So I think there's an argument. I don't think there's an argument either way that one's faster. And trusses cost. You're all that engineering costs money. It's not for free. Back. But they are convenient though, and they're great for if your crew's not real experienced in site built roofs, then that'll be much easier for them to do a truss because they're just all by the numbers. There's a stair. The next page 9 just shows you what a typical stairway looks like. All the stairs, you have an exact space from one floor to the next. And so that all the stairs have to be exactly the same height. So there's math that allows you to make that happen. And the framing class we do in fall if we do it. I think we'll go over that. The math class, we'll go over that too. The second half of math class is stair framing and roof framing, the math involved. So you get it twice. You get it theoretically in the math, and then in the framing class, we do a stairwell and the roof framing class, we do roofs. So you get it again, and it's nice to get it. You can get it 10 times. Still wouldn't be too much. Yeah, the rest of this, trying to think of anything that's really important. Oh, yeah, this is important. We'll go over it later, but on page 13. And again, those of you who work with this know this pretty well, but they used to make, there used to be no difference between a nominal size, which is what the wood's called, like a 2x4, 2 inches by 4 inches, and the actual size. It used to be 2 inches by 4 inches. But along the way, they started skimping on it, and everybody has a different answer for why they did that. In this country, it's got to be money. So if they could make, they could sell a 2x4 that was 1.5 by 3.5, and they save a lot of money. I mean, a lot of money. I suspect that had to do with it. And the engineers probably put a halt at 3.5. They said no more because we've allowed you 24 or 16 on center with a full 2x4. You're not going under that. That makes everything confusing because the name's been there forever, but then the size is different. So this table has the different sizes, and what's really a bummer is that they don't stick to this because and I have a perfect example. I was doing a shelf in my bathroom, just a utility shelf, and I bought, I wanted to buy wood. I'm really good at economizing wood, and I figure out exactly what I need, and I go see what they have. So I bought a 6-foot piece of 1 by 10, and then 2 8-foot pieces, and they were going to be the shelves, and the 6-foot piece I was going to cut in half for 3-foot sides. I got the whole thing built before I noticed that the 6-foot piece was 3/16 less wide than the other pieces. So it's a utility shelf, so you can't hardly notice it. Who cares? And when I was younger and I knew what I was doing, I wasn't in such a hurry. When I get to wood, I would measure it all, and then I would go into the table saw and I'd rip everything to the smallest dimension so they'd all be the same. But it really ticks me off that they don't standardize the widths anymore.
Yeah.
It's gotten a lot worse. So you really need to check. You really need to check that, or you need to be a good enough carpenter you can, on the spot, compensate. And most carpenters can, but when you're beginning, it's really a pain in the ass to have it different. Right.
Usually everything under a 6-inch is to the half.
Yeah.
6 is 5.5.
Yeah,
But when you start getting up into 7s,
exactly. That they've kept the 2x4 and the 2x6 close. It still varies from 1/2 to 5/8. And that may be because it's wet. The difference between wet and kiln dry. There's all that too. But he's right. Once you get to the 2x8, 10s and 12s.
they go to a quarter.
Oh,
Goes to
well,
7
but I
1/4.
mean, the difference, sometimes you can have a 9.5
Yeah.
or even more. I mean, and that's really, it's hopeless. But anyway, this is the table. You've got 1 by dimension, that's 3/4 for finished stuff. And then you've got the 2 by, and this, I think this has most of it. So it's got the nominal, so you call it by this nominal size, like a 1 by 2 or a 1 by 12. So it'd be 3/4 by, it would be a 3/4 inch piece, but so 3/4 thick, but the actual width instead of 12 would be 11 1/4. And that's no longer standard. They were all like Eric said, they were all 1/4 inch, 9 1/4. No, yeah, 9 1/4, 11 1/4, and what am I missing? 7 1/4. 7 1/4. Those last 3 were all 1/4. First 2 were half, last 3 were 1/4. Easy to remember. Now the 1/4 can be anywhere from 1/8 to 3/4. I swear. Or
I think it's just when the wood dries out a lot.
Maybe.
It shrinks.
I hope nobody's intentionally doing that. Yeah, so that's something else you got to take into consideration. But anyway, when I was saying, sometimes they draw it as a 2x4 on a floor plan, they'll draw it 3.5, which is actually what it is. Other times they'll draw it 4 because that's the nominal size and it's easier to, you have to read that 1/2 inch, it's small on 1/4 scale. So you get them both ways. But that's, anyway, memorize that if you're going into this industry, because, your boss will say, go get a 1 by 12. You gotta, you get there, go, there's nothing here that's 1 by 12. You'll be there an hour. Boss, I don't know. Yeah. Oh, foundations on 14. There's just some different, the upside down T is a common foundation, and of course slabs, thickened slab. A slab has to support walls, so they have a, various, it used to be you could go with 3, but I think, what's the minimum slab now? 6? 4. Used to be 3, now it's 4. I think in some places it might be more. And then the end has to support all the way to the wall. So it's like a raised foundation. You've got, you know, stem wall and a footing. That's huge. But a slab, you don't have it. So you got to thicken that slab at the edge. So they call them thickened slab. And there's a whole, you know, there's a whole way that's required to do that. The size and stuff you have to use in that. That's pretty important, knowing the difference between a slab and a raised foundation, because those are the two types we have here. 15 repeats that typical wall. You know, it's funny. You know how various groups get into civil rights, and they object to the terminology that's been used in the past, like dwarves don't like to be called dwarves, they like to be called little people, you know, that kind of thing.
Really?
Yeah. So things change, even though dwarf is a scientific term for a certain type of growth. But so with curtailed studs, they didn't like crippled. They used to call them crippled stud because that meant short. It didn't refer to crippled, but crippled people took offense to that at some point in the 60s. And so they started calling them curtailed stud. Curtailed, but can you imagine a builder spelling curtailed?
But I never heard it. This is the first time I hear
Well,
it.
it didn't last
Okay.
because everyone went, come on, this is bullshit. And it is, because nobody thinks about that, you know, except crippled people. And they're not even called crippled. I don't know what you would call them.
Disabled.
I guess maybe handicapped, right? Would be the proper term. But the studs, you know, it's just another medium. It's got nothing to do with that. So. But every time I'll see it every once in a while, it's something I'll just laugh. We went through that phase.
You got the stud and then you got the cripple.
Yeah. Oh, so look at 14. Here's a stairwell. This is out of the, we've got it in our other book we use, the Modern Carpentry. This picture is similar, but see how that stairwell on the right, that header that heads off those joists is thicker than the one on the left. In a good drawing, it would show a double and a single. But this is another 14. But it's single on the left because it's so close to that wall that you don't have to support it so much. The other one's more out in the open, so that's how I was thinking.
Right.
And it's wide.
Yeah, and then sometimes partition support on the left, if you have a wall that's parallel to the joist, right underneath it, and it's right in between two, say it's 24 on center, and it's right in that 12 inch, it's going to weigh on the plywood. There's not going to be, so then you need to block between that. And there's various ways to block it depending on where it is in that void. So that happens. There's a 16, there's a picture of a truss with the sheathing on it. Now we have to use those plywood, those panel clips, because when hurricane force wind will pull off sheathing, so now you kind of connect them all together with those clips. And now actually we have to put what do you call it? A strap across the top of the rafters. Hold them together. We can't just nail them into the. Yeah.
Say that again. What is that called?
You know, you have two rafters coming together on a ridge.
Mhm.
You got to put a strap across on
Oh,
the
okay,
outside, a metal strap. So that the strong winds can't blow that apart. You know, the winds will probably get stronger too, along with everything else, right? Well, they are on the East Coast, right? The hurricanes will get stronger. We get hurricanes, right? We get stuff
But don't the Channel Islands block it?
what's that?
Don't the Channel Islands block it?
Yeah, they block a lot of it, but
Down in Baja, you get.
Baja, you get them. Sometimes they come up if we get to like the edge of it.
Yeah.
Yeah. So. And that could all change too, but you're right, the islands, I don't think about the islands. Save a lot. This is an unbelievable place, partly because of those. And then this stuff about on 18, how the sill plate sits on the car, that's not important for now. You know, it depends on how you want to line up all the siding and insulation and stuff, so. And we'll look at the foundation stuff that's at the end here later when we look at foundation plan. So that's all we need to do. And what's is framing plans actually on the sub? So let's do, yeah, we've been here a long time. Let's do framing plans with next week's sections and elevations and midterm prep. That stuff won't take so long. So we got a little bit of a background. If you're new to this, go home and look this over again. Sure. And then the first part, then we'll look at some framing plans in our plans. And we'll look at sections and elevations. That'll be really interesting. And then that means, that's tomorrow. I guess that's what I do tomorrow day, is I get the prep ready. Damn, I was gonna go for a bike ride. No, guess I'm not. Okay. Brutal schedule. Yeah, so tomorrow's important because it's the prep for the midterm. So. You hear that, guys?
That came fast.
I know. I double checked it. I thought, that's not right. And I looked and I went, no. If you wait too long, then the final will be right on top of it.
So is the midterm next Monday or Tuesday?
Tuesday, Monday, we don't have.
Monday's a holiday, so
holiday next Monday?
you have more time to study, but you really don't need to study much. I prepped you pretty good. If you want to study, you got more time. Yeah, so I'll remind you again tomorrow, because nobody has a memory past the day. But the Monday after, a week from today is a holiday. It's Memorial Day, right? Isn't that what it is? One of those?
Yeah, it's Memorial Day.
Memorial.
Yeah, I know, I always get them mixed up. If it was my dad's generation, we'd know what the labor one was.
Memorial, but
Yeah, Memorial's from the war,
yeah, that's usually when
the memories of dead soldiers. I wish we'd stop having wars and we could get rid of that holiday. But not yet. Not yet. Okay, so yeah, so framing plans, yeah, that'll be fun, and the elevations are fun. And then I'll have yes, sir. Yeah, any question?
So
You can go, it's a general question, you think?
It's about.
Okay,
the
real
hold-ons that
quick,
you
and
were-
then I'll let everybody go. That's okay, real quick.
Okay, like here you can see on this, on page 18,
Yeah,
you can see the anchor bolts that you were talking about.
Yes.
The hold downs that Eric was mentioning, they go all the way up here.
yes,
all the way down to the foundation.
yeah.
To
From the
these- to these-
foundation, they
to
go
these
all the
modules
way
right here.
through the floor system into the wall.
And then.
Because the walls
because
are pulling away from the floor because they're just nailed. Earthquakes love nails.
They have these brackets that holds onto the studs.
Yeah, I'll bring one in.
Right.
Yeah, we usually have one over there, but I'll check it out. I'll bring both of them.
Louis,
Pretty interesting, yeah. Well, the framing part, we go into that, we don't have we show all that stuff. But did you take a framing?
I only did through.
Yeah.
No,
So framing,
right at the-
just to let you know, has
I guess what?
hardware.
Oh, hey, thank you.
That's
So, no worries, yeah.
No, it's not just us, it's hurricane people too. Florida has the same kind of. how it works.
Hey, thanks, Pastor, after tomorrow.
That's-
Yeah, you're welcome.
I'll see you tomorrow.
Okay, yeah. See you guys. Thank you.
I got.
Yeah, I mean, you don't really.
Are the plants staying on the table?
Yeah.
That's how I did.
Yeah. Sometimes the others clean on.
The only time you want to use that other.
But they
See you tomorrow, Pat, have a good evening.
Yeah, these times it's really so hot, right?
Thank you.
Yep.
Yeah, have a good one.
Okay, you guys, that.
He's gonna-
Cool, let me know, how much.
So I need to, one good thing about a Tuesday class is I can finish the video. But then I have to come back Wednesday. Yeah.
Right.
Oh, well.
Trade ticket for ticket, yeah.